right. Good morning, everyone. Are you ready for another day of DevOps? A little. How were the sessions yesterday? Did you enjoy it? Okay, at least 2 people enjoyed it. So I've been here a couple of times, and these rooms never cease to amaze me. Like great seats, don't fall asleep, but that's my job. Huge screens, and Stefan also has these fancy live, what do you call them? Live subtitlers, right? So let's test them how well they work by saying something like, I don't know, a monad is just a monoid in the category of endofunctors. Not too bad, a monad. A monad could be a monad, right? We can say that. Pretty good. So what DevOps also does right is give speakers a presence. So I received this present this morning. It's a barbecue, well, what do you call these in English? Apron, barbecue apron. And I'll stand in front of the camera so you can see. It says 404, diet not found. I guess that's about right for me, so I'll be using this in the summer for some barbecue. So thanks a lot for joining. We're going to be talking about other things in the next 3 hours. So we're going to talk about Java, about Quarkus, about GraalVM, about native images, about AWS Lambda, about DynamoDB, and even more. So my name is Bert Jan Schrijver. I am CTO at OpenValue. I like to explain CTO as Chief Troublemaker Officer, which is about right. OpenValue is part of Tech Tribes, a platform of specialized IT companies. I'm also in the board of the NLJUG, the Netherlands Java User Group. Do you have any members of the Netherlands Java User Group in the audience? Well, at least 3. Did you get your JFL ticket? Yes. Good, then you're one of the lucky few. We sold out in a couple of seconds. I'm also a volunteer at the ISAQB, the International Software Architecture Qualification Board. This is a foundation that focuses on providing software architecture education. There's a booth from the ISAQB at the exhibition hall. I'll be there tomorrow, so feel free to step by and talk software architecture. So, what are we going to talk about? This talk revolves about something I built for the NLJUG. So it's about the backend for the events that the NLJUG organizes, like JFall and JSpring. So I'll tell you a little bit about that. I'll talk about the architecture for the backend, where the most interesting stuff is going on. I'll give you an introduction into the world of serverless computing. I'll talk about GraalVM. We'll talk a lot about Quarkus. Then we demos. I'll share how I migrate an application from Spring to Quarkus and why I did this. I'll share lots of experiences from running these applications in production during a couple of conferences. And if time permits, we have some bonus topics, lots of room for questions, etc. So remember, I'm not here for me. I'm here for you. So we have loads of time. 3 hours is heaps of time. So by all means, if you have any questions, raise your hand. Hopefully you can see it. Just wave frantically and we'll be good. Interrupt me, shout things at me, whatever you can do to get my attention. So I'd love you to leave this room at the end with little to no questions about the stuff I'm going to share. So please ask questions and let's see if we can build this session together to make it as fun and as informative for you as possible. So about the NLJUG. Well, we already knew there's a couple of members in here. So the NLJUG is a foundation and the goal of the NLJUG is to promote the use of Java in the Netherlands. So it's been around for well, over 15 years, over 20 years even. And the NLJUG organizes a couple of conferences, JFall and JSpring. JFall is comparable to DevOps, I would say. We have around 1,800 people who gather in the Netherlands every November. JSpring being its a smaller event, about 800 people. The NLJUG also publishes a magazine, the Java magazine. So we got a printed magazine delivered to your doorstep 4 times a year. So if you live in the Netherlands, you're not a member of the NLJUG yet. It's pretty cheap. You get to go to JFall for free. And in general, those are good events, I would say. I'm a bit biased because I organize them, obviously. So for the events that we organize, we have a mobile app. And this mobile app is basically an empty shell where you can load contents for multiple events in there. And this was created for us by the Dutch tax service, which is one of our partners. So if any of you are paying tax in the Netherlands, thank you for your support for this app. So how does this app look? Well, about what you would expect. It's pretty similar to the Devoxx mobile companion that Stefan created for Devoxx. Once you open it, you can pick events. So it's an app we use for multiple events. When you select an event, there's some background. So there's some information about the conference, some information about partners, etc. There's obviously a list of sessions. You can scroll to them. You can favorite sessions, make your own program. Once you open a session, you can see details about the session, you can see details about the speaker, and most importantly, you can rate sessions. So you can give a score from 1 to 5 stars, 5 being the best, and you can share feedback, hopefully anything nice about the speaker. So the architecture is quite simple. There's a mobile app, it's there for iOS and for Android. It needs the internet. It will get all its content from an S3 bucket, so basically an object store. You can see there's a web server, and all the votes that people do get sent to a backend. And this session mainly revolves around this backend. So to give you an idea on how the data flow works in the app, well, the user opens an app, then the app goes to S3 to get overall metadata, and a list of events is returned. This is all JSON. So we can now display the list of events that you just saw. Then once you pick an event, some metadata about the event is downloaded. So the colors, so we show the app in different colors, a link to the event content, which by itself is another piece of JSON that's on S3. Well, then you can download the event content. The event content contains the highlights, so the stuff about speakers, about the sponsors, speaker information, session information, and then the app can show the event, basically. So once you open the list of sessions, then, well, we need to show speaker images. We're not prefetching those all right from the start, so there will be a loop. Once you scroll, those speaker images that are in view will get downloaded and shown on your device in the session list. Well, is this interesting? Not really, I would say, because this all comes from S3. It's super fast, super scalable. You won't ever get performance issues there. What is fun to mention is that this architecture of fetching this piece of data and this data model was designed almost 10 years ago and hasn't changed since. So I think that's interesting to realize about this. So then the backend. This is where it gets interesting. So we first built this backend, well, about 10 years ago, with technology that was common 10 years ago. So it was running on AWS already. So it was running on EC2, which is basically VMs in Amazon that you can easily scale out. There was a load balancer up front that will divide traffic over the different nodes. And on those nodes, there was running a Java.E application on Java 7 and Wildfly 8, which was common in 2015. Then there was an EC2 instance with MySQL running the database, and that was basically it. So the downside of this was that load balancers and EC2 images cost money to run. So what I usually would do is, after the conference, throw all the infrastructure away, then let it not run for almost a year, and then build everything up again when a new conference would come along. And then scale along a little bit. So these EC2 instances, they were, I think, small instances. Those cost a couple of tens of euros a month. I would run on one instance during testing and then scale to 4 or 8 instances how I saw fit. But this was not auto-scaling by any means. Just I knew that if I run on 4 instances, it could take the traffic of a JFall event. So at JFall, there's about 1,800 people. So worst case, we get like 1,800 requests per second on the app, which is not that much. Depending on how fast everything is. MySQL was not clustered or anything, so I would just scale it vertically, get a bit bigger machine right before the event, and then scale it down afterwards. And then the cost of this would be, I think, around, in a conference month, 100 to 200 euros, and then I would throw everything away again, and then it was 0 euros for the rest of the year. But still pretty expensive in terms of infrastructure. So I was working with my colleague Tim at the Dutch police at the time, and Tim said, "You're doing it all wrong." So I said, "Why, Tim? What am I doing wrong?" He said, "Well, this is the ideal case for a serverless solution. I said, serverless, what do you mean? What does it even mean, serverless? Well, Tim explained me that serverless computing is about running functions, basically. It's often called FAS, functions as a service. So you deploy something small, can be a piece of JavaScript, TypeScript, Python, Java, whatever you want. And these functions usually do some small task. They're often short running. So handle one request and then stop again, or handle one batch process and stop again. They often have small units of execution. So usually a program or anything that performs the tasks and then stop. So not huge Java.E or huge Spring applications, but small pieces that can start and execute fast. So what compares serverless computing to, let's say, regular computing? If you run on a VM or on Kubernetes or whatever, it's all on demand. So by default, if you deploy your serverless application, there's nothing running. So there's nothing running until you get your first request. And when you get your first request, your serverless platform will find your code, start it up, handle the request, process everything, send the response. And then usually it scales back to 0 instances after a while. So often after 15 minutes of no traffic, your function gets killed again. Which is fine if you have, I don't know, a piece of Python code running that starts up super fast. But what if you have a Spring app that you need to start up a JVM? Spring starts up, it does class path scanning, it needs to load all your proxies, all your Hibernate or Spring Data stuff. How long does it take in general to start up your Spring app? Just shout. Let's talk in terms of seconds. 30? 30, okay. Anyone else? 15? I was hoping it would be close more than a couple of seconds, but I love the examples. But 30 seconds is a great example. Let's say that my serverless function is scaled back to 0, and you do a request. At this point, the runtime starting up your Spring application. So you're waiting. JVM starts up. JVM starts in maybe a second or 2 seconds, right? Then your Spring app starts up, 10, 20. 30. After 30 seconds, now it's started up. Now it can start processing your request. How long does processing a request take? Well, hopefully, I don't know, 300 milliseconds or something, right? But maybe it's a bit heavy. The caches are not filled because your application just started up, so it needs to fill some caches. Well, maybe 2-3 seconds. Then you can send the response. So how long has the user been waiting? Well, a couple of milliseconds to start up the serverless container, 2 seconds to start up your JVM, 30 seconds to start up your Spring app, and then half a second for your request. So all in all, 35 seconds, and then you get the response. How many of you would be delighted to use an application where it takes 35 seconds to get your response? How many of you? No one? No, no one. Not me even. So scaling back to 0 has implications for startup time, obviously. The good part of serverless computation is that you pay per use. So you usually pay per, I think it's megabyte second, megabyte CPU second. So you have a certain amount of memory assigned, you have a certain amount of CPUs assigned, and then what you pay is how many megabytes of RAM did you use and how many CPU seconds did you use. So using 2 megabytes in 2 seconds costs about the same as using 4 megabytes in 1 second, basically. So because of this, memory usage also matters, because this is what you pay, and CPU cycles also. So because of this, obviously, startup time matters for cold starts. You can have cold starts, this is where there's nothing, everything needs to start up. You can also have a warm start. If you're lucky, the app is still running. So for example, Amazon Lambda scales back Lambdas usually after, I think, 15 minutes of inactivity. So if your Lambda is down, has no request for 15 minutes, then it goes back to 0. There are ways around this. So for example, you could write a script that calls your Lambda to keep it hot every 14 minutes or something. It also means that you're paying when it's not actually being used. So the nice thing about serverless is that you're only paying when there's an actual request, which works super well for a conference app, because let's say that the DevOps companion app for DevOps, this has a lot of requests around October and no requests during the rest of the year, right? So if you were paying for the full year, you're basically paying a lot of money for no usage at all. So obviously, startup time is a challenge for Java apps. We already talked about this, right? Be aware there are still servers. So just with the cloud, there's not really a cloud. It's just someone else's computer, right? Serverless, the same thing. You don't really manage those servers. You don't really care about them. They are still there. They can still break, be slow, all the lovely things you have when you manage the servers yourself as well. So let's talk about my first serverless experience, and it was in 2016. In 2016, the Amazon Echo Dot came out. It was like the competitor to Google Home, and I need to get it in the UK because I wanted to play with it. After a long time paying way too much money, I got it, and then I started looking into how can I program stuff for this. And it turned out, well, it being Amazon, you needed to run stuff on Amazon Lambda for this. So my first experience was somewhere in December 2016. So I got this Echo Dot set up. I connected it to my AWS account. And then in order to process voice commands in here, I needed to write a piece of Java code, compile the Java code. In general, if you run plain Java on Lambda, you need to interpret some sort of interface. There's like a handler interface that gives you the request parameters and some context. So implement this interface, compile the code into a jar file, upload it via the web interface to Amazon Lambda, and then good to go. And then it didn't work, and then you had no idea how, so trying out left and right a little bit, and the result was this.
Alexa, tell me what's the best day?
Wednesday is the best day, of course. Friday is alright, but not as good as Wednesday.
Well, that was an amazing use case, as you can see, right? But it was a bit painful because of needing to write the code locally, compiling it with a certain Java version, with a certain JDK distribution in a jar file, uploading it via the web interface, having not really a way to debug this, so it felt fairly painful. Well, things went on, and I decided to modernize the stack for the NLJUG app backend. And the second iteration, I moved to Spring. So most of the blue parts were still the same. I was running on EC2, which is the Elastic Compute Cloud, just let's say VMs at Amazon. The load balancer was still there because the load balancer needs to distribute traffic to those different instances. But now I went for Spring. I built in Spring Boot 2 and Java 8, which was common in 2018, I hope. And I replaced the database with something else, AWS DynamoDB. Have any of you heard about DynamoDB before? Well, that's quite a lot. That's maybe another 20 of you. So for the other 400 in the room, DynamoDB is a serverless database. Serverless basically meaning you don't need to care about how and where it runs. It is fully managed by Amazon, so you don't need to do anything there. It's distributed, so it can scale easily, and it's a NoSQL database. So basically what you put in there is JSON or key value pairs. You don't need to manage everything there, anything there. There's no maintenance for downtime. It's just always there. It scales instantly, so I've never had performance issues with it. And you pay per request. So basically, you pay for the amount of read units and write units that are consumed. So in the early days, I needed to provision a certain amount of read and write units. So say, okay, I need, I don't know, 100 write units per minute or something, and 50 read units. But now this is all auto-scaling, so you don't need to configure anything anymore. And there's a super generous free tier. I don't think I've paid a dime to Amazon for the DynamoDB offering so far. So about money and Amazon, people often complain that you pay lots of money to Amazon, which is true if you run a considerable application. But if you run something small, it's actually super cheap because Lambda, we'll look at that in a bit, but you can get, I think, like 1 million requests to an API gateway for free per month. And I don't know how many hundreds of minutes of free compute time. So I was talking, I think even last year here, I was talking to some people from the Lambda team at the AWS booth. And the guy said that they have a problem with internally with the success of Lambda, that it's not making enough money. And I said, why is it not making enough money? Because it's an amazing technology. Yeah, we offer it for too cheap. So since it's so cheap to use, there's not many companies paying a lot of money to Amazon for using Lambda, or in this case, DynamoDB. So let me show you a little bit about how DynamoDB looks. I have the database for the NLJUG backend here. So what's funny, it's NoSQL, right? Fast and flexible database, but there's still tables. So I don't know, MongoDB, sorry about this. MongoDB calls this collections, I guess, but well, it's still tables. Let me log in here. Obviously, I prepared this all super well. I was signed in a couple of minutes ago, but not again anymore. There's still table. Well, it's called tables, but they're key value pairs. So you can basically store JSON in there or strings or whatever you want. Obviously, I'm a good citizen, so I have MFA as well. Any questions so far? I won't be able to see you, but feel free to shout them. So it's all really clear, or either really clear or really boring, which is both fine. So here are our tables, right? So there are two NLJUG events and NLJUG event sessions. Sessions is well, not really a super interesting table. There's just session informations there. So you can basically explore data in the table, and you can see how it looks. So let's get something from well, JFL 2024. What's in here? There's a code, an ID, basically for the session. There's a title, and there's an array of speakers in there. And in this case, it was Parajay Banerjee who was a speaker. So this is just a cross-reference to get data about sessions. So the actual votes are in here. So what you see here is some stats, like there's 25,000 items in there. It's only 4 megabytes. Capacity mode is on demand, which means that it will scale whenever you need something. The average item size is 160 bytes. And then the read-write capacity, you can either say, have like guaranteed read-write capacity, or you can say it's on demand, and that will scale automatically. It hasn't scaled anything in the past couple of days because, well, it's not being used now. There are some indexes you can place there. So here's like the warm throughput it can help. It can basically process. You can create indexes, which are you create on usually a certain field or a partition key. Partition key describes how data is sharded basically over multiple instances. So if you shard, you usually divide your data over multiple instances of a database by using some kind of partition key. In this case, it's partitioned per event ID, so we can read all data from one event from the same partition instance, which speeds up things a little bit. I haven't really found much differences in using indexes or not on this database as compared to if you, I don't know, do a SQL database, then indexes help a lot to speed stuff up. Here, it didn't really matter that much. So we can explore items from the table. Obviously, not all of them because that's quite a lot. In this case, this is a vote for JSpring. There's a unique ID for this vote. The answer was 5, so that's 1 out of 5 stars. 5 is pretty good, and it was for session JSpring 2025-21. You can also sometimes give comments. Let's see if well, here's a comment for a JFL session. From JFL 22, how do you rate it? It was a 4, and the comment is, look at the screen while presenting. I'm not sure what the comment means. Is it an instruction for the speaker to look at the screen more while presenting, or maybe the speaker looked at the screen too much while presenting? This is in general how DynamoDB looks. It's pretty comparable to something like MongoDB or any of those other NoSQL databases. So even though I was doing a serverless database, Tim still said to me, that's fine, but your backend is still not serverless. Which was right, because the backend was still Spring on AWS. So I've made multiple attempts to go serverless. And most of them during hackathons with my team at Open Value. This is a picture from this summer, where my colleague Kees is explaining something about, I don't know, probably solving observability challenges with AI or something like this. So my first attempt to do something actually meaningful serverless, apart from the Echo Dot voice control things, was in 2019. So in 2019, GraalVM had just came out, or maybe a year or 2 years, And I'd heard about GraalVM native images, and I'd also learned that you can run a custom runtime on Amazon Lambda. So with Amazon Lambda, there's basically two ways to run it. Either you run on one of their existing runtimes, so there's Python runtime, JavaScript, TypeScript, a Java runtime. Then Amazon provides basically the environment that your code runs on. With Java, it provides a JVM that loads your classes, etc. But you still have like JVM startup time. You can also do a custom runtime. In a custom runtime, you're basically giving Amazon a Linux binary. So it's in this case, it was an x86 Linux ELF binary that basically got to run on an Amazon Linux instance. And the nice thing about this is that you fully control whatever runs there. Probably Amazon just runs a Docker container, and inside this Docker container, your Linux binary starts up. And you can put everything in there what you want. So in my case, I looked into GraalVM, and I used a how-to by Paulo Lopez from the Vertex team to build a native image into a custom Lambda runtime. So how this went is the Lambda runtime at that time was Amazon Linux x86 ELF binary, so a random like Intel Linux machine. And in order to build a custom runtime, you would need to compile your code into a binary that was supported by this Linux x86 ELF runtime. So at the time, how I did this is I started up an Amazon Linux machine at Amazon. I wrote my code locally, then copied my code to that machine, compiled it there with GraalVM to a custom binary, so it was the right binary format, downloaded it again, then uploaded it to the Amazon web interface, ran it, and then it ran. Amazing, but super painful. And the native image stuff in 2019 was pretty slow. So that worked, but it wasn't really feeling like a nice development process. So a little bit about GraalVM. How many of you have, probably everyone, how many of you have heard about GraalVM before? How many of you is using GraalVM? Okay, that's like 5, 6. How many of you is using GraalVM native images? That's 3. Okay, so there's still stuff to learn for the rest of you. So GraalVM is both a Java development kit, so you can write and compile code with it, and a Java virtual machine, so you can run code on it. Oracle builds it, which is fine. There's two options to run it. You can run it as a JVM, where it's based on a hotspot, with JIT. Well, those are a lot of abbreviations. A JIT is a just-in-time compiler. So basically how the process when running in JVM mode works with any JVM is, well, you write your Java code, you compile it into Java classes, and Java classes basically are a certain format that are platform independent. So whenever those Java classes get loaded, there's a just-in-time compiler that reads this Java bytecode and then translates it to the platform-specific code. So if you run the class on Linux, it gets translated to Linux instructions on x86, and if you run it on macOS on ARM, there's an interpreter that goes, just-in-time compiler that goes from your bytecode to ARM. So this is the platform-specific part. And the JIT is pretty good because it can also do optimization. So it will, for example, there's a couple of tiers of compilation. When your application first gets loaded, everything is compiled to your platform-specific stuff and then executed. But the JIT also continuously basically analyzes your Java code and makes optimizations. So sometimes it sees that a certain branch of code is never used, so it can filter out a piece of code. Whenever you do enter that flow of your code, the JIT gets reset and needs to start it up again. But in general, by not continuously, but regularly inspecting your code and how it's used, the JIT optimizes how your code runs. So this is why long-running Java applications typically perform pretty well, because the JIT is continuously optimizing whatever is going on there. But you can also run GraalVM with ahead-of-time compilation to a platform-specific native image binary. So that's a big sentence, right? Let's chop that up in parts. Ahead-of-time compilation, which means that the stuff that the JIT usually is doing afterwards, so you write your Java class, you compile it, you create a jar, you run it on a JVM, and then the JIT kicks in on the target machine where you're running. With ahead-of-time compilation, you're pulling all the stuff to your compilation phase, which has plus sides and downsides. So a downside is that you need to do a lot more work during the compilation phase. The plus side is you need to do a lot less work in the runtime phase. So one of the reasons that a JVM may take time to start up is because of the JIT that kicks in and the actual stuff that needs to be translated to your target platform once the application starts up. With ahead of time compilation, you're putting this all the way to the compilation phase. So you are creating a platform-specific binary now. So it's not write once, run everywhere. It's write once, only run on the target platform you've compiled to. So you're compiling to a, let's say, an ARM64 binary to run on Linux, or an x86 binary to run on, I don't know, something else. You're also compiling to a native image binary. So your whole application, whereas, in the JVM, on the JVM side, you would have your jar file within there, your classes and those kind of things. And then on the server, there's your JVM running with all the libraries there. And this whole thing runs your app. With GraalVM, you're just going to one single binary. And that one single binary has everything. It has the stuff that's in your application. It has the stuff that your JVM usually needs to run. Just one single binary, good to go. So this is also super interesting to create, for example, command line tools. Because you can get your Java application and compile it into one binary that you can distribute to other people. You do need to create different binaries for different target platforms. So if you want to support Mac and Linux and Windows, then you need to create 3 binaries. But this is perfectly doable with modern cloud-based runners. So stuff that like GitHub Actions or GitLab pipelines. It's easy to run your build 3 times for a different target platform. So there are obviously benefits. Native images are super small. You'll see during the demos. Both in terms of disk space, but who cares? Disks are cheap. And in terms of memory. Memory, low memory footprint does make sense. We'll see that later on. It starts super fast. Why does it start super fast? Any ideas? No JIT, exactly. There's no JIT. At least someone paid attention. There's no JIT, so all the work is already done, and it's already in the actual binary form that the CPU of your target platform needs to run. So there are drawbacks, obviously. It is static compilation, so you compile everything beforehand. So you have no dynamic class loading, no reflection, etc. So whereas you may be used to use reflection to load classes or to lazy load dynamic classes or whatever, not going to happen because you don't have a compiler, you don't really have a class loader. So will Spring work on GraalVM as a native image? Yes, it does. Obviously, it didn't before, but Spring, there's now Spring Native, so you can build native images with Spring and GraalVM as well. It was difficult in the beginning because Spring does loads and loads of dynamic class path scanning and loading, but it works now. I haven't tried with it, but I've heard it works. So in the meantime, while I was figuring out what GraalVM was and struggling with native images and deploying them to whatever, Tim is freaking presenting here at DevOps about building GraalVM native image stuff with Quarkus. So I learned about something else, something new. So Quarkus, well, probably you've all heard about Quarkus before. How many of you have used Quarkus? That's about half of you, I would say, maybe 1/3 to half. The others are the rest is using Spring. Raise your hand if you're using Spring. Who's doing something else then but Quarkus and Spring? No one. Okay, so sorry for the Vertex people, Micronaut, Helidon, Play, Spray, any of those. Only Spring and Quarkus people. So Quarkus is aimed to be Kubernetes native. What does it mean? Well, it runs well on Kubernetes, basically. It's open source. Red Hat builds it, and it's designed to work well with the Java ecosystem in general. So it's tailored to run both on OpenJDK hotspot, so then you have JIT and long-running optimization, but it's also tailored to run on GraalVM. And the developer experience is pretty good, if I would say myself. I love playing and building stuff with Quarkus. So then I did my second serverless attempt. So you see that we skipped a couple of years. A pandemic happened, and I didn't need a conference app backend for a couple of years. Back in 2022, we were back at it again, and hackathon with the Open Value team. And then I started with Quarkus and with GraalVM and native image generation. And it became pretty doable back then. So still a bit painful because, well, it was 2022, so new Macs had come out. And I had this one, which is an M1 Mac, and M1 has an ARM processor architecture. And at that time, Amazon Lambda only supported Intel processor architecture, which means that if I build a native image here, I cannot run it on Amazon Lambda because the processor architecture is different. So there's two ways to solve this. Either the same way as I did before, get a Linux machine at Amazon, rsync your code there, build a native image there, download it again, deploy it to Lambda, which was okay, but a bit painful. I chose to do it with cross-compilation. So then you need a Docker image that basically takes your code and then cross-compiles it to the desired target architecture. This works, but it was slow, like at least 15, 20 minutes for a build slow. And I'm an impatient dude, right? So didn't work at all for me. There were some new tools that I'll also show you in a bit that helped. There was SAM, which is a serverless application model, which helped me easily build and deploy stuff. So it was fine, but the cross-compilation still made it a bit of a pain. Then a year later came my third serverless attempt, and now Amazon supported an ARM runtime. So now it clicked, I can build an ARM native image on my machine, throw this directly to Lambda, run it there, profit. So I updated whatever I had to build it now on an ARM64, and now stuff was, well, GraalVM had improved also along the way. Now it turned out to be super fast. So I could build a native image in maybe 1 or a couple of minutes, upload it, and well, you'll see it during demo, but this is all pretty quick now. So I guess the time wasn't there when I was doing this before. So now why it worked was Quarkus had improved, Amazon SAM, the serverless application model, had improved, GraalVM had improved, and I could now do ARM64 both on my machine and on Amazon Lambda. So this was on June 10, and on June 14, so a couple of days later, I had migrated everything from Spring and JVM on EC2 instances to Quarkus, GraalVM, native images, Lambda, etc. So that was pretty good. Just a couple of days work while having a couple of beers in between. So finally, Tim was happy. I don't know who the guy on the right is, but let's not talk about him for a while. So the third iteration of the app backend. You can see that the overall blue boxes are still pretty much the same, right? So there's something here that basically multiplexes request over something that's here. DynamoDB is still the same. Pretty much only this changed. So I went from Amazon Elastic Load Balancer to Amazon API Gateway, which does pretty much the same. Request gets in and distribute requests over whatever is back there, with the difference that API Gateway costs almost nothing. And if you get an Amazon Load Balancer, Amazon instantiates an EC2 instance for you where it runs, I don't know, some load balancer software, and you pay like at least 30 euros a month just having this load balancer running. With API Gateway, it's more of a shared hosting platform, and you pay per request, but you get like, I think 1 million requests for free per month, which is not how many requests this app gets. So now it's, instead of Spring, it's Quarkus. It was now Java 17, and it was now GraalVM native image running on Amazon Lambda. DynamoDB part unchanged, still the same as it was before. So that was already serverless. So it's time to start demoing to show you how this all looks. Any questions so far? Yes. Isn't there direct function calls now in AWS, and don't you need the API gateway? Yes. So I will show this in a bit when I deploy stuff. So lambdas are pieces of code that run that respond on events. And basically, you can throw any type of event to them. It can be like a SQS queue, API gateway, load balancer, something from all Lambda. You can also invoke lambdas directly over HTTP. Why I use an API gateway? Because of 2 reasons. First, the stuff that Quarkus gave me gave me an API gateway. And secondly, on API gateway, you can also set stuff like API keys. You can configure stuff like throttling. You can also configure custom domain names and TLS certificates on there. So I like to have the abstraction. In general, you can have any trigger you want to call a Lambda. So for example, there's also Amazon has a CloudWatch, which is their generic logging and monitoring and data framework. So you can create alarms on CloudWatch if the response time go above this, or if this log entry happens, and that in itself is an event, and those events can also trigger Lambdas. So basically anything that happens in AWS, you can use to trigger a Lambda and do whatever you want. So you could also see it as some kind of a way to customize and build stuff that responds on stuff that happens in Lambda. Any other questions so far? I do need questions for you, otherwise we're going to finish early. I love your I love your participation. Yeah. Yeah. So when you're doing the build process for this, is it managed in a pipeline? It depends on however you do this. So I'll show you two ways. Most of the stuff I run on my laptop is perfectly fine to run this in build pipelines as well. In general, there's a command line tool that you use to deploy stuff. So let's start with a demo. So this guide is on the Quarkus side is the guide provided by the Quarkus team. How to do Amazon Lambda with a couple of different flavors of doing HTTP in Quarkus. If you go to the Quarkus.io site, it's the AWS Lambda HTTP guide. Well, it's considered preview technology, but well, let's just run preview in production, that's fine. What do you need? 30 minutes, we have 30 minutes in IDE. You need Java 17 or higher, you need Maven. You can use the Quarkus CLI. You either need GraalVM installed on your machine, or in my case, you can do the native image build in a Docker image. So you don't need any of the GraalVM stuff on your machine. You need an Amazon account, which you can get almost for free, and you need the Amazon SAM CLI. So Amazon SAM is the serverless application model. And the serverless application model is both a, let's say, a templating language to define serverless application, and it's also a CLI, a command line interface that you can use to interface with Amazon. So once you install these things, you have the AWS command. And with AWS, well, there's loads of stuff you can do, but it's basically a CLI you can use to control your Amazon account. Just to be sure that I'm using the right credentials here, because I have both a demo account and the NLJUG production account. In this case, I'm using the demo account, which is fine, so we'll be good to go. The SAM client is called SAM, and with SAM you can do stuff like init to create an app, build it, local to run stuff locally, deploy, get logs, test, get traces. It's just a simple command line interface for interfacing with the Lambda stuff on Amazon. So back to the guide. Well, you need to install the Amazon stuff. Then there's a Maven project. There's two ways. You can either do the AWS Gateway HTTP API, where you can do whatever you want with HTTP, or you can go for REST. So what I wanted was a development experience where on my local machine, I'm just using Quarkus and building REST endpoints like I'm used to, and then press a button and get all this good stuff on Amazon. But it's not trivial, because if you deploy a Lambda on Amazon, Amazon Lambda Java example, you usually need to basically implement some kind of interface. So here's a function, and what it does is it implements request handler, and then some order and a string. So there's a handle request, so you get, in this case, your event and some context. So any Lambda you build yourself, you need to implement this interface. You get an event that has usually the request and some context. But this is not REST, right? So this is just, I don't know what's in the event here, but some stuff about the request, maybe some HTTP parameters, but I just want a regular REST interface. So the archetype for Amazon Lambda REST helps you there. So let's generate this. Let's get the right Java version first. And generate. All right, so let's go for org.NLJUG as the group ID, lambda demo. Yes, okay, so there's a lambda demo here. Let's open it in IntelliJ. And let's make it a little bit bigger for you. Okay, so what do we have here? There's a POM. And this POM has, well, some versions. That's not too interesting. There's, it's using the Quarkus, let's see, the Quarkus BOM as dependency management. So all the versions are aligned with whatever the current Quarkus version is. And then here you get 4 options. You can use JAX-RS for REST stuff. You can use servlets with undertow. You can use Vertex, which is a reactive toolkit for the JVM. And you can use Funky, which sounds funky. It's some kind of function implementation from the Quarkus team. Then there's Amazon Lambda REST, because that's what I wanted. There's JUnit Rest Assured for testing. There's the Quarkus Maven plugin to build, compiler, Surefire to run integration tests. And then here there's the native image profile that well, basically configures some logging for integration tests, and then sets here Quarkus native enabled. So this instructs Quarkus to build a native image, basically. So this is still the stock generated demo. Let's see what's in there. There are 4 classes in there. So let's start with resource. This is just a plain JAX-RS resource, right? It listens on /hello. It produces text plain, and it says hello JAX-RS. So let's see how this runs. Exit presentation mode, then go here. And then who's the right Java version? Maven Quarkus dev. This is going to be a bit small for you, but you should be fine. Okay, so Maven build, and then it starts running in Quarkus development mode. So if I now go to localhost 8080/hello, then it says hello JAX-RS. But I could even say, if I go to, well, I need to be in my right IntelliJ here. And if I say hello JAX-RS from Devox, and I now go back to the browser and I reload, it reloads instantly. So the development experience with Quarkus is pretty neat. Somehow they got to get the Quarkus dev mode so fast that you can change anything in your app. It will reload pretty much instantly. Obviously, this is a trivial app, so if you have a bigger app, it may be a bit slower, but still pretty good. Let's change this back, otherwise maybe my tests will fail. Reload again, and you see it's back again there. So what else do we have? There's a servlet, which is, well, if you're feeling old school, you can just do get, do post. You can write a server response to your Lambda. There's Vertex. In Vertex, you need to basically do everything on routing context. So you say hello Vertex to respond. Then there's Funky. I have no idea, well, where this goes to, if you call it. It's not HTTP, but we can have a look. Anyone interested in how Funky works? At least 3 people. That's enough to Quarkus Funky. It's part of Quarkus serverless strategy. So here there's a greeting function, a POJO input and output. Probably this responds on events, I guess. How to call Quarkus Funky. There's an HTTP binding as well, so you can do it over the HTTP. But I'm guessing. Oh, you can still do HTTP here. You can map it to HTTP request. I'm guessing that usually this will respond to some kind of event. Because, well, in functions, you don't necessarily need to have everything over HTTP. You can also have them respond to different events in Lambda, or if you're running on other serverless runtimes. So this is pretty much it. There are some config files being generated while you build, but in general, this is the template you get. You can take and deploy this all to Amazon Lambda if you want. So this is nice, but I was missing a little bit of ease to use here. So instead of using this, I created a template project that's free for you to use as well. And this is over here. So if you want to follow along with your laptop, go to github.com/BertJan, and there's a project called Quarkus, GraalVM, AWS Lambda, ARM64. And this project is based on the Maven archetype I just shown you, but has some extra stuff. So let's first go back to the guide by the Quarkus team. So you can build it using the Quarkus CLI or using Maven. You can do a native build. We'll look at that in a bit as well. These are the config files we're going to look at. You can run stuff locally that I will show to you in a bit. We can skip about this. You can run the native image locally. You can deploy. We'll look at that as well. We've examined the POM. We'll look at that later. You can inject context variables. So if you need some stuff from the Amazon Lambda context, you can get to those as well, or the specific API gateway event. In my case, I don't use this. I just go plain REST and take whatever REST request comes in there. I don't need anything else from the API gateway. But you may use this, for example, to read, I don't know, authentication properties from the request or anything like this. This is examples about how you can create resources. We'll look at that in a bit as well. Some stuff about authentication. We won't be looking at that. Yeah, this is all about how you set up like user principles with Cogito and those kind of things. Yeah, that's about it. So let's go to the template I created and see what's there. That's here. So there's quite an extensive README here on what you need. So what you need, in my case, an ARM machine, because this is set up on for ARM, so Mac M1 to M4. It works perfectly fine on Intel or x86 as well. You just need to change the deployment target when you're going to deploy to AWS. You need Maven, an AWS account. I have the AWS CLI installed. We just saw that. I have the SAM CLI installed. Well, it was generated using the same archetype as you just saw. And I will open the project here. And if we run it, then we should be able to run the Quarkus dev mode as well. Hopefully I killed the other one. Localhost 8080, hello. Oh, no, this is the wrong one. Let me go to, because this is the actual production serverless app, I need to be here. This window. Good that I checked. Maven Quarkus dev. Let's get this away. Yes, let's get the right Java version as well. Sorry about this, I activated some hotkey. This one. It needs to run at least Java 17 to run, which is fine. And now it says hi from NLJUG. Okay, so let's have a look at this project. Stop Quarkus again, and what do we have here? It's pretty much the same structure as we just saw, right? So there's source, there's just one resource, and there's one resource, there's a JAX-RS resource that says hello. You can put whatever you want in here in terms of JAX-RS. The annotations and stuff, if you use to Spring, also pretty much the same. There's some tests in here. There's an integration test that will start up Quarkus to see if everything runs. There's a unit test that will try my JAX-RS. Well, it's also an integration test that will try my JAX-RS endpoint. And here's the resource, and there's some config files in here, and some scripts that we'll be looking at in a bit. So back to this here. So Quarkus dev, we did that. So if you do this, then you have just local development mode. Again here, super fast reloading. So now it says hide from NLJUG. If I change it to hide from DevOps, reload, and it's there instantly. But let's start looking into native images now, because now I want to basically build this as a native image and see if that works. So what should we do to do that? Well, it's in the how-to, obviously. We can run a script, and the script is called build.sh. So let's look at the script. What this says is Maven package -d native, which activates the native profile. runs in a container, and then uses a container image from Quay to build. So just to check that, or basically to prove to you this is actually the same as the demo project that I just shown you, let's grab the POM from the demo project, which is this one, and put it down here in my Lambda template project, POM2, and compare those. No, it doesn't need to be in Git. Okay, so on the left we have my template project. On the right we have the generated one. Well, the name is different. Let's move that over. The Quarkus plugin version here. Well, that's a variable in my project, so that's fine as well. Well, the template project said only use one, so let's remove Quarkus and those other things. Sorry, the Quarkus REST and funky and those kind of things. So there's one change here. This is a variable, so we can move that over as well. Yeah, so the only change in my template in the POM compared to the archetype is that I've added Quarkus REST-easy JSON-B. So this is for JSON binding. So you can take Java records and serialize them and deserialize them to JSON. This is not by default in the Quarkus stuff, at least when I set it up a while ago. So it's now time for us to build our first native image. Let's see what this will bring us. Quarkus, Lambda, no, Quarkus, how's the project called? Quarkus GraalVM. All right, let's see if I have the right JDK. Yes, scripts, let's look at the script again. Build.sh, so package it in a native profile, use a container to build, and use a Quay container to build this. So what this is going to do is it's going to build my stuff, but basically the Java stuff on my machine with Maven. Then it's going to pull a container image from Quay container registry, and then do the native image build in that container. That means that I don't need to have a GraalVM installation on my machine, and it means it can use all the build tools that are provided in that container, which simplifies the build process a little bit. So there's no GraalVM on my machine, just a regular OpenJDK, and by using this container, I get to basically get to build it inside a container. Oh, sorry, I don't need to deploy. Let's build it. I get to do a regular Maven build here, and then pull a container, and in this container, the GraalVM native image build will start. So it has done just a regular Maven build here, run some integration tests, and now the native image build starts. So it's running the native image plugin on Mandrel Linux, a huge Docker command, and here the GraalVM stuff starts. So this is an 8-step process, and it takes about a minute on my Mac. So during I think it was a JSpring speaker dinner a while ago, I was talking to Fabio Niephaus, who works at Oracle at the GraalVM team, and he told me that he had worked on the progress indicator here. So the progress indicator of the native image build, and that it was quite a challenge to get this all working on different platforms, different ASCII characters, get a progress indicator that actually made sense with colors, those kind of things. So yeah, he was proud of his work at this progress indicator. So what's all going on here? We're initializing, there's some information about the Graal compiler, there are some specific features that Quarkus configured, there are some experimental options that we unlocked. We are using about 5 GB of memory, 10 threads, and then well, it's going to perform an analysis of basically my code base and the Java stuff it needs. So it's building, parsing, inlining basically means that you can inlining is that you can make stuff in methods more compact, so it runs faster. Compiling, creating an image, and then it's done. Let's skip this because I'm going to show you later. Now you can see what all is in here. So the top origins of code. We have 12 megabyte of Java base. That's, I would say, pretty small, right? 12 megabyte. Because how big is a JDK on disk? Any thoughts? 150? This is OpenJDK. Wait, that shouldn't be right. No, 0 bytes. Let's go here. well, this is 500 megabytes, but I guess it's usually more like, yeah, so OpenJDK is 300 megabytes for JDK. Obviously, there's lots of stuff in there that you don't use if you run a Java app on there, but it is there on disk. So in this case, it's 12 megabytes for Java base, which is nice. Jackson data bind is 1.86. SVM is the substrate VM. That's the working title for the VM in GraalVM. So substrate VM, project for the technology behind GraalVM native image. All right, what else do we have? This is my actual code. So my app is 1.2 megabytes, but it's trivial. It only says hello. Then Vertex is in there, which is a reactive framework. Netty is in there for network stuff. JBoss for the rest easy stuff. Then some more Jackson for Jackson Core. Vertex ATP, some more Netty, etc. And then you see also that it's done analysis on my heap. So, well, there's 4 megabytes of strings, 3 megabytes of classes, etc. So this is also what happens when you make a native image, is that your application is actually start up, and there's sort of a snapshot being made of the objects that are in memory, and those are put in your native image as well, which makes it start up even faster. So there's some runtime analysis going on. So I said it took about a minute. Well, it's exactly a minute. So in 1 minute, the native image has been built. And we can now also run this locally. I have a script called run local. This is going to copy some config that we'll look at a bit, and then use the SAM, the serverless application model, to start an API and reference to the SAM native config file. So let's have a look there. So what this does is it pulls a container, I think from Amazon, that mimics the Amazon Lambda runtime environment, and then runs it on localhost 3000. So if I go here, I should be able to say hello. And when I do this, it will decompress my function and then start up the Quarkus app, and then we're good to go. So the first time starting locally may take some time. For the version now, it's pretty much instantly, right? So it said it was going to uncompress function.zip, right? So this function.zip is my entire native image. So it has everything in there that you need to run Java, which is usually like, I don't know, we saw 300 megabytes. It has all the stuff in from Quarkus, from Jackson, from REST Easy, and my code. I'm going to let you guess how big this function.zip is. Yes, let's come with your numbers. 3, are we talking 3 gigabytes, 3 megabytes, 3 kilobytes? Just 3. Oh, that's about right. If we add some numbers there, you'll probably be good. What do you think? How big do you think it will be? 42. 42 is a great answer as well. Anything between 3 and 42. That's probably accurate. So the zip file is 20 megabytes. So if we unzip it, then there's only one file, bootstrap, and this is 59 megabytes. So it's well, it's a little bit bigger than 42, but zipped is a bit less than 42, and 59 maybe in order like a multiplier of 3, right? So I'll give it to you both. You're pretty good. So now we can run this thing locally, and next step that we're going to do is to deploy it to the cloud. But first thing is I want to show you how the turnaround time is to deploy stuff. So let's say that I have it running now, right? So run local, and let's say I want to change something here. So I want to change hide from NLJUG here to hide from DevOps. Okay, so what I need to do, I showed you how fast it was in the development mode, right? That was like half a second or something. If I want to change it in my app now, hide from NLJUG 2, now I need to do a build and a new native image build, and need to start up the local container again. So to time this, I'm going to run this command. So I'm going to run the build, and I'm going to execute the run local script. How long do you think this will take, this local cycle? Yeah, so it was about a minute for the build, so 1 minute 30 sounds about right. There are test failures. Well, this is great. I changed something here, so then I should change it here as well, right? Because otherwise my tests don't work. So let's try again. So it was about, well, let's say 1 second or half a second in the local dev mode, and now to run the native image, build it again, and run locally will probably be like about 1.5 minutes or something, which is, well, a little bit painful maybe. So this is the downside of working with native images. The compilation step takes a lot longer than if you're just building stuff for your JDK. Sorry, for your JVM. On the other side, I hardly ever need to run stuff locally as a native image. Sometimes to test, but usually when the VM stuff runs fine locally, I just deploy it to Amazon and it runs fine there as well, with some little exceptions that we'll see a bit later during the session. So I need to be ready to refresh, because then we can stop the timer. Well, here we are again. Let's be quick, because localhost 3000, hello. No, press the wrong button. Well, I just guess we can deduct 10 seconds, right? Decompressing, now it's there, and it took 1 minute 20. So it's about a minute, but mainly the native image build time and then running locally. So this is a bit painful, but it's okay, because you don't need to run the native image stuff locally that much. All right, so let's see what's next. Yes, so we're about to deploy, but first let's give you a short break. Go get something to drink, visit the toilet if you need, and then we'll continue in about 15 minutes from now. So let's continue at 55. Let's continue at, no, sorry, 66, 40, 50. Let's continue at 10:52. See you in a bit. All right, I said 52. And then it turned out to be 54, because apparently I can't count. We are exactly halfway this session, which means we still have a lot more time. And while I was walking out here, well, first of all, I almost wouldn't have made it back, because I went out. I went to the toilet, and when I came back, I realized that this was here. So then the security wouldn't let me in. And then I had to convince them that I was wearing a microphone and that you would all be angry and would come running out looking for me if I wouldn't make it back to the room. And then he said, okay, no, those people look pretty scary, so I'll let you through. So I got quite some questions while walking around here during the break, and I'd like to address some of them. So one gentleman asked me, like, yeah, so you're talking about frameworks and deployment scenarios and JVMs and native images, and can you shed some light there? So I think it's good to understand this. There's three axes that we're talking about here. So the first one is, which framework do you choose to build your stuff? So it can be Quarkus or Spring or whatever. Most of you are using Quarkus and Spring. Second is, where do you deploy your stuff? Do you run your stuff locally? Do you run it on a server that's somewhere in your broom closet in your office? Do you run it in containers? Do you run it on like a virtual machine that you rent somewhere? Do you run it on Kubernetes? Do you run it on Lambda? This is basically your deployment service. That's the second axis. And then the third axis is, given your framework and your deployment service, what's the shape of where you're deploying your stuff in? So in all those variants, you can both run in virtual machine mode, which means there's a Java virtual machine running on your deployment surface. On this, you're copying your app, your jar, your EAR, your var, your zip file with classes, whatever, your single Java class file, or with newer versions, even a Java source file you can run on a JVM. Or the other option is you package it as a native image. Then you don't need Java installed on the target machine. But you do need to have a native image that was built specifically for the target machine. So basically, we can make permutations between any of those. So stuff you're probably all familiar with is you're running Spring on a Java virtual machine on your local machine. In this case, you start up Java command, you start up your Spring app, the app is there you go. Probably, once you push this to your build server, a Docker image gets built where the JVM is copied in the Docker image or probably already in the base image. Your application is copied in there, and when it starts up, your application runs. What I'm specifically showing here is Quarkus. So this is the framework we're using. Let's say the shape of what we're deploying is a native image. Well, not really. Locally, I'm running on the Java virtual machine that just loads my Quarkus app like regular, like just when you're running Spring locally. But once I build into a native image, and this native image is going to deploy to Amazon Lambda. So could you also run Spring on a Java virtual machine on Amazon Lambda? Sure, you can. Nothing keeping you from there. But the downside is that probably the startup time will be a lot longer than a native image. And as a result, a user needs to wait for everything to start up before the request is handled. So can you do Spring as a native image on Amazon Lambda? Yes, there's a Spring native project that I've heard works pretty well. So you can also build those Spring things as a native image. Can you run Quarkus on a JVM in Kubernetes? Yes. Can you run Quarkus as a native image on Kubernetes? Yes, given that you package your native image binary in a Docker image and then run this Docker image in Kubernetes. So you can see these three things pretty much independent. Which framework do you use? Which deployment surface do you use? So virtual machine, Lambda, container, Kubernetes, whatever. And then which basically deployment shape do you use? So it can be either classes running on a Java virtual machine that will be interpreted by JIT, or a native image that's for a specific target platform. And then another question I got was the native image stuff. Do you really need the native image stuff to be able to quickly start up on Amazon Lambda or any other serverless solution? The answer is it's just one of the options you have. So there's also tools like AWS has SnapStart. And what SnapStart does is you can start up your application and then basically make a snapshot of the virtual machine. So there's two ways. You can either make a snapshot of let's say the whole Linux machine. So you're basically snapshotting just like you would snapshot a VM or VM or something. There's also on a JVM level, there's CRAC. So CRAC stands for CRAC. It stands for Coordinated Restore at Checkpoint. And with CRAC, you can basically write a snapshot of your current JVM and its memory space to disk. And then you can move this stuff to another machine, start it up there, and it will start up from the snapshot you took. So these are alternative ways to have quick startup in cloud environments, in Lambda environments. So either use Amazon SnapStart that will basically snapstart your whole Linux VM or your Docker container, or use CRAC that will allow you to store the state of your JVM on disk and restart from there. Should you use GraalVM native image, or should you use SnapStart, or should you use CRAC, or any other stuff that starts up really fast? Well, the answer is it depends. If somebody tells you it depends, then you immediately respond with on what, and the answer is what would work for you. So if you have a trivial application like me, where you're starting from scratch, there's no boundaries. GraalVM works perfectly, it's easy to do. If you have an application that you've been building for 10 years, wow, then maybe getting into a native image may be difficult. Because, and this is another question I got, limitations of native images. There is no just-in-time compiler, there is no class loader. So if your application relies on filling classes and optimizing long-running processes, then maybe running on a JVM will be the most performant way to run your application. If you're doing stuff with reflection, so you're loading classes dynamically because if you have a plugin structure for your application, or you have some lazy loading of stuff, then GraalVM probably is also not going to work because you cannot load classes dynamically. So in that case, staying where you currently are, Java, Spring, Jakarta EE, Quarkus, wherever, and then finding another angle to solving the startup problem on Lambda. But you can also ask yourself, is serverless really for me? Because for let's say a typical administrative application, application for the police where you file police reports, or application for the tax service where you file your tax returns, this probably has at least some traffic during the entire year. So then it's fine that this application is continuously running. And this may be the case for like 95% of the stuff you're building. So only for the 5% where you have highly dynamic traffic, like a conference app, no traffic 364 days a year, a lot of traffic 1 day a year. In those cases, serverless may work. A benefit of serverless is also not that it can scale back to 0, but it can scale really fast to 100,000, 2,000 instances, and then scale back really fast again. So it's also the elasticity that serverless stuff brings you. Yeah, and then I got a question about Quarkus versus Spring and maturity. How mature is Quarkus? Well, let's ask the internet. Spring framework release date. Spring was released in 2003, so that's a while ago, right? That's over 20 years ago. Quarkus, I think like 2018 or something, 2019. So this is 6 years. So about maturity, well, purely in terms of age, Spring has been around for a lot longer, right? Quarkus is being actively developed by a group of people at Red Hat and obviously community contributors. So I'd say Quarkus is relatively mature. It's perfectly fine to run in production, run your production workloads on it. Also because Quarkus is not necessarily completely new. It uses loads of technologies that we saw when we were exploring the native image, like some JBoss stuff, REST Easy, Vertex, Netty, that has been around for years, right? It's more of like an opinionated combination of all those things, and on top a lot of new things, like the plugins and those kind of things, the native image support. So I'd say Spring, obviously, in terms of how long it's been around, is a lot more mature. Instead of using it in terms of using it for production workloads, we use it for production workloads at quite some customers, so that's fine, no troubles there. You may be able to find maybe a bit more like extensions or guides or plugins for Spring, but that's just because it's been around for way longer. Yeah, and then I got another question, but this kind of plugs into the earlier question. Can you run native images on other runtimes than Lambda? By all means, I'm running it on my local machine here. You can package it in a Docker image, run it in the Docker image. You could run it on Kubernetes, anywhere you want. It's just a binary. The only difference is that if you deploy, if you create your Java app locally, you're creating Java classes, Java bytecode, and this is being run on a Java virtual machine. And a Java virtual machine takes care of the platform independent part. So while you're writing your Java code, you don't need to care about what target platform I'm running on. If you're building a native image, you do need to care about the target platform in terms of CPU architecture, where you're going to run on. But this is also, you can make a problem of your pipelines, for example. So that was another question that I got. I'm now doing everything locally, and I'm also going to deploy from my machine to Amazon locally without using any pipelines. Is this a good idea? Well, if you're the only developer on the project like this, it's fine. If your CPU architecture is the same as production, it's fine. I would not advise you to do this for any serious project, but I'll also show you that it's perfectly doable to put this into build pipelines. You'll just do whatever I do here. Make sure you have a build image that has the Amazon CLI, has it configured, that has the SAM CLI, has it configured, and you can just run the same scripts I'm running on my machine in your GitLab or GitHub or Bitbucket pipelines. Let's see. Yes, we have this, we have this, we have this, we have this. Yeah, so I got a question about reflection and third-party libraries. I'll show you a bit during the demo later. So all the stuff that's standard in Quarkus, so all the Quarkus stuff, all the plugins you can get, those are pretty much battle tested with GraalVM native image. But if you pull in, for example, a third-party caching implementation or a caching framework, that may not have been tested with native images. And then you may find out that it works fine on your local machine, then you deploy it to Lambda and you get some kind of no reflection available error or something because it's trying to dynamically load some implementation. There are ways around this. So you can annotate methods or classes with @register for reflection. This instructs the native image processor that this class is going to do stuff reflectively and will allow the native image processor to do the reflection stuff at build time. So in the end, it will work. Yeah, so with third-party libraries, it depends on whether this has been tested and works with native images. So this is why I do advise to, before you first go live, when you add a new dependency, first run it on your local machine or your test environment. But in general, that's advice you can apply to any change you make in an application, right? And also, when is GraalVM not a good fit? And in general, we should divide GraalVM in running it as a virtual machine, and then it's pretty much the same as running like any OpenJDK build or Azul or whatever, and running as native images. I think we could reverse the question and ask, when are native images a good fit? And I think they're a good fit when startup time really matters, and when resource usage really matters. So if for some reason you need to run with the littlest amount of memory possible, littlest amount of CPU, you need stuff to start up fast, perform fast, then GraalVM is a good fit. On the other hand, if you are running on some cloud provider and you have gigabytes and terabytes of memory, who cares? You can just run on a JVM in a Kubernetes instance or whatever. Maybe you need an extra Kubernetes instance compared to what you would need with GraalVM native image. But on the other hand, the extra cloud cost will be maybe, I don't know, 10, 20 euros a month. And if you would compare this to the extra developer costs you would need to train all your developers to use GraalVM, well, then it's an easy trade-off, right? So in my case, I've seen a couple of usages of GraalVM. So here the fit is perfect because it's a trivial application, it's quick to build, it starts up super fast, it scales back to zero super fast, fine. We also run a project for, well, let's say a bit more serious client where we build an extranet that runs on GraalVM. This is one of the bonus topics I have that I hope to be able to share you at the end of this session. I hope to also share a bit later about experiences with bigger companies and whether or not you can use Docker. Hopefully we have time there. Questions usually lead to follow-up questions. Have my answers triggered any follow-up questions? Yes, over there. Yeah, so the question is about the learning curve between Spring and Quarkus. It's an interesting question, and I think it's not really honest. I cannot really give an honest answer. So I started out in the 2000s with servlets. So I learned about Java and servlets and Tomcat and those kind of things. And then from there I moved a little bit to Java.E. So then you learn about WebSphere. Have anyone worked with WebSphere before? Do you still remember what it says when it starts up? Yes, so when WebSphere starts up, it says server 1 ready for e-business. So I'm like, yes, let's go do some e-business, people. So WebSphere, which is a Jakarta, well, nowadays we say Jakarta-E, then Java-E application container. So then you write your code against the Jakarta-E APIs, and then WebSphere implements for you. Then I moved to Spring, which was, I don't know, like 2014 or something. And then I started doing Quarkus a couple of years ago. So I started doing Quarkus, having already extensive Jakarta-E experience and Spring experience. And then it's quite easy to learn, because you're basically in Quarkus programming against most of the Jakarta-E APIs. So there's JAX-RS, and there's CDI for injection, and there's the Jakarta-E security specification. In general, if you're starting from scratch, I'd say they're comparable. You need to learn about the intricacies of the framework. In Spring, there's obviously lots of dynamic class loading going on, which may be a bit difficult to debug. There's also development tools for Spring that makes you reload quickly. The same is with Quarkus. I don't know. Quarkus felt quite easy for me to learn, but this was after I already had experience with Spring and Jakarta-E, so it's not really a fair comparison. So I wouldn't say that one of them is a lot more difficult to learn. At least if you've used one of them, the other will be pretty easy to learn. Any other follow-up questions? How about execution speed? Of what and where and when? Yes. So performance in how fast your application runs. Yes, that's an interesting question. That's also difficult to answer because it would highly depend on the use case. If I'm talking about from the time my application starts up first till it has completed this task, by all means, native image wins by a mile. If it's a long-running application that has concurrency and those kind of things, it will highly depend on your workload, I would say. So obviously, there's in you run in JVM mode, there's the JIT, which optimizes along the way compared to the workload you get. I wouldn't necessarily say that the one of the other is faster. The only clear difference for me is that native images use less resources and start up a lot faster. I don't know. I'm not going to say anything that either makes the people at Oracle mad or the people at GraalVM. So I wouldn't really know. Any other questions so far?
It was just a side note, but if you start up a Lambda and it needs to read from AWS Secret Manager,
Yeah.
that takes a lot of time.
Yeah. Yeah.
Like not a good idea.
Yeah, so a side note that if you start up a Lambda, it needs to read from something in AWS, it can take a lot of time, but that's not really a Quarkus or native image problem, that's more of a Lambda runtime problem, right? Yeah. So in my case, my Lambda is pretty much independent. It doesn't need to read anything from the environment, it's just ready to go. The authentication that you will see later is built in, but it's trivial as well. There was another question over there, yeah? Is there a possibility to run a test against a native image? Yes, you can. There's multiple ways. So you can either run SAM, the SAM CLI to start it up on some machine, like I showed on my machine. You can also find a machine that has the same CPU architecture as your production environment and start up the native image there. It's just starting up a binary. It will start up, in this case, wow. You're with the Lambda stuff that's around there, right? So then probably starting it with the SAM CLI on a test environment will be the best way to run a test against it. But it probably will not be super respective in terms of performance compared to what you're doing in production. But how I would set this up is have my local development on my machine, then have some Lambda where I would deploy it, where it runs as my test environment, run my test against there, and have some Lambda where I run as my production environment, because then also the runtime is comparable between test and production. But in general, I think using the SAM CLI to start it up is the closest you can get to actual running on AWS Lambda. Test containers, yes, could work as well. In general, that's what SAM pretty much does. SAM starts up the Amazon Lambda container and then runs your API, your native image in there. All right, let's move on, because it's now time to, after over 1 hour and a half, finally start deploying some stuff, right? So where are we? I'll show you the Amazon account and prove you that it's empty. So I'm here at Amazon Lambda, and there's nothing here. No services here. If I go to API Gateway, there's also nothing here as well. Well, there should be nothing here as well. Nothing here as well. So let's start deploy. First, I'm going to show you the config files that are in here. So there's the config for SAM, which is the SAM CLI. And basically what SAM does is it creates CloudFormation scripts. So CloudFormation is Amazon's infrastructure as code tooling. So SAM basically creates CloudFormation and then triggers a CloudFormation run on Amazon. So the CloudFormation stack name is serverless API. It uploads my application to an S3 bucket, which is an object store, and then CloudFormation will pull it from there. It's in EUS 1. I don't want to confirm anything. I don't really know what this means and this means, but it was there when I generated it, so I just went along. Just an honest answer. Then here is the most interesting file. So this is the SAM descriptor for my application. We're going to skip the commented out stuff for now, and we'll look at that later. So, well, there's a version here, some format description. We're configuring our endpoints to be regional, and we allow any binary media types. This has something to do with how Quarkus handles requests. And let me look this up. Quarkus Lambda. There's an incompatibility, I think. The API assumes that response bodies are text unless you explicitly tell it. So to make this easier, Quarkus forces binary 64 encoding of everything. So we must configure the API gateway to assume all media types are binary. I've never really cared about this. This was just in a template and it turns out to work. So if it works, but you don't know how it works, well, you can either start figuring out how it works or just believe that it works and went along. I did the last thing. So I'm going to deploy a serverless API resource. It's an AWS serverless function. The architecture is ARM64. If you have a Linux, an Intel box and you want to deploy on Intel, change it here to x86. The handler is usually points to the handler class that you're deploying. So this is the Java class that implements the AWS Lambda interface. But we don't have it here because this is all handled by Quarkus. So, but the Quarkus Lambda plugin. So the example I showed before, my Java code needed to implement some kind of Amazon API interface, basically Java interface, to get the request and the context. This is all abstracted away by the plugins here. So I'm just writing a REST application, and the Quarkus Lambda stuff implements the handler, redirects to my application, proxies everything, etc. The runtime is a provided runtime, Amazon Linux 2. My code is in function.zip. It's 256 megabytes max memory, which is plenty. There's some policy on there that you need to set up once you get started, but this is all in the how-to on my GitHub. Timeout is 15, which is probably 15 seconds, which is good to check. SAM template timeout. Default is 3 seconds. Oh, so it's then probably. Oh, this is probably not when it scales down, but when it stops processing. So in terms of when it will get killed, because Amazon wants your lambdas to live shortly. So this is probably the request timeout. So if your request takes longer than 15 seconds to respond, Amazon will kill it, which sounds reasonable. I don't want my users to wait longer than 15 seconds. There are some environment variables. I think this is also a Quarkus intricacy. That's probably on this page as well. Resolves some incompatibilities between Quarkus and the Amazon Lambda runtime environment. Fine, if you need to do this, we will do it. Well, it responds to events, so any Lambda responds to events. In this case, an API, and it will proxy anything to my serverless API deployment. From my service API deployment, I think. So this is the service API deployment. This is a REST API. There are some properties here. The stage name will reference the variable stage. The endpoint configuration is regional, whatever that means. And here are some parameters. These are basically variables that you can put in your SAM template. So the stage is a string. A stage is something, API gateway can have multiple stages. So you can use the same URL to point it to different lambdas. Maybe you have /test, /prod, /something. In my case, there's only one stage. I named it prod, so my URL will be something /prod. You can also call it API or v1. It's a matter of how you will set this up in production. Will you have one API gateway that goes to all your test environments, or will you have maybe even separate AWS accounts? I probably would set it up if I have a test environment that there's 2 separate AWS environments or accounts, and they all have their own API gateway, so I can test changes in my IPAs for tonight. API gateway to test them independently of each other. Then it outputs some stuff. What is the URL and the CloudFormation stack name? So we've already built our application. That was here, right? We built in 1 minute, so now we can deploy. So let's have a look at our deploy script. This will copy the config files that I just shared to my target folder, because that's where AWS reads something. It will also copy this config file here, because I've noticed that sometimes, I don't know, it will read it from the current folder. I didn't really catch why. I just copied it twice and then forgot about it, which is, well, engineering-wise, not super nice, but if it works, it works. So now we're going to run our deploy script. So deploy script will start by uploading my function.zip, which has the file bootstrap, which is a native image, to Amazon. And then it will trigger a CloudFormation run. So if I now go to the Amazon console and open CloudFormation, you should be able to see a run going on there. Here it is, serverless API, create in progress. So, this isn't really super interesting to have a look at, because we can also see it here in the command line. But what's happening now, it's going to create a CloudFormation stack. is going to create an IAM role that it probably needs to handle some access stuff. Now it's going to create an API resource, which is the API gateway. It's going to make an API deployment, and it's going to make an API deployment, and going to deploy a Lambda, etc., etc., etc. Boom, we're already done. There should be something over here. So here's /prod. What was the URL of my REST endpoint again? Do you remember? Hello/hello. Well, here it is. Hi from NLJUG 2. So in the past, I don't know, how long did this take? Like a minute or so, the complete AWS environment was created just by what was written down in this SAM deployment file. So there was nothing in the AWS environment before. Well, one thing, but I'll tell you later. Everything was now created. So from a clean AWS environment, you can go to a deployed API gateway and Lambda in a minute or so. So let's see what it created. So the CloudFormation run should probably be, yeah, it's complete. Okay, so probably, well, we can click here. It created a serverless API. And this is, this is serverless API stack. Probably I should be able to jump to the API resource as well, right? Yeah, so this is a Lambda function that has been deployed. Lambda function, serverless API resource. So there's this one file here, it's called Bootstrap. I'm not able to edit it here because it's too big. It's that 20 megabyte we looked at. So if we open this resource, we should be able to see, yeah, some kind of an architecture diagram. So here's my Lambda. The Lambda has my GraalVM native image and responds to events. Those events are sent by this API gateway. So basically, an HTTP request gets sent as an event to my API resource. So if we go to the, here is the endpoint. So it's some URL /stage, which is prod, and it proxies everything. If we go to this API gateway, we should be able to see it here. So here's stage prod, and it goes to / and it will proxy everything, everything there. Let's see, is there anything else to show here? Not that much interesting yet. There's also monitoring on here. So there's some monitoring on the API gateway, but also on the Lambda. So we can see how it is and what types of requests it gets, etc. So let's see if we can make Amazon sweat a little. So I'm going to, this was the URL. So let's use curl to make a request, prod /hello. Well, now it's there. So now we have 2 requests, 3. Let's run this in a loop. So let's go for, let's see, while true, do curl that thing, done. So now you see that it processes about 1 request per second. That's probably because the default limit will be throttling by 1 request per second. So that's not that much. But we can obviously also run stuff in the background, right? So let's go, let's see. Yes. So what I'm going to do is take this while loop, and instead of say curl, call that thing, run a shell command. So this will still do the same. But now I'm going to run a shell command in the background. So it's going to fire loads and loads of curl requests on my Linux terminal in the background, and then see how much calls we do. So I hope my credit card is okay. Okay, stopped it. So now we did, I don't know, a couple of 100 requests, right? So what will happen is Amazon will well, process the request to the API gateway, transfer them all to the Lambda, and maybe even scale the Lambda a little bit. Let's just do it again to make sure that Amazon has some work to do. Okay, let's not forget to turn this off, because then otherwise I will get an AWS bill. Now, it will take some time for Amazon to process the stuff and show it here. So probably usually a couple of minutes or something. Let's show the average of a couple of minutes. Maybe a bit more, the last 15 minutes. So you already see some stuff going on here. So the number of invocations was 1, and then here it was 3, because I just did a couple of calls in the browser. This is interesting. So the response time, it went from 530 milliseconds, the maximum, to 1 millisecond, and the average was 2. So this is different between a cold start and a warm start. So the cold start, Lambda has not run before, takes 500 milliseconds to start up and to respond to my request, which is still fine, half a second for a cold start, right? But a warm start, it was like 1.2 seconds or something, which is pretty fast. So let's see if the others are already here. Yes, so now invocations, we went from, 1 to, I did 1800 invocations. So what happened with the number of lambdas? Total convert executions. It started with 1, and it scaled to 140 lambdas. So because I was sending 1.8K requests, Amazon decided to scale to 140 lambdas in parallel, and then probably it will scale back to 0 anytime in the future. Any other stuff that we can see here that's interesting? Not really. Error count. There were no errors. Probably in a couple of minutes or so, we will see it scale back again. Let's see if we can see something in the API gateway as well. If I go here, API gateway, because this API gateway should show pretty much the same stats. Serverless API, and then let's see where I can monitor it. No, that's on this stage, I guess. No, I have no idea where this would be. Stages, prod. There should be some monitoring for the API gateway as well. Dashboard, there it is. And then here the API calls, but this is stage. You need to go to prod. Yeah, so here there were. This is the first run. So we can click to CloudWatch. We'll see in a bit more detail. And only go last couple of minutes or so. This is a bit small. Let me see if I can. No, not really, right? If I put this down, yeah. So this was the first. This was me yesterday testing. We're now here. So this was the first, I think, performance test I did. I went from 1 request to 2.5K requests. Let's see if we can. Yeah, there's not much more to do here. In a while, the second batch of requests will be there, or probably this is already the second batch because we do 2.9 here. Let's go back to the Lambda and see if we refresh, if the second one is there. Oh yeah, so here we see that the duration peaked until like 6:25, and then got back again. So why is there a peak here? Because it was fast here, and then it peaked here, and then it got down here again. Why do we have a peak here where it's relatively slow, 600 milliseconds? Any ideas? Yes, we're scaling. So all those new lambdas, those 143, they all have their first cold start request. So they all may take a couple of 100 milliseconds. We also see that it already scaled down again here. So we started with 1, then we went to 143, and then once I stopped sending stuff, we scaled back to like 9. Probably because Amazon thinks, oh wow, I was pretty busy just a couple of minutes ago. I just keep 9 running in the case that another performance test comes along, and it will scale back to 1 or 0 anytime in the future. What else is there to show? Let's see. Yeah, I can show some logs. So this will basically say SAM logs. And this will connect to CloudWatch, which is Amazon's observability system. So there's metrics in there, logs, etc. And I will get the logs from my Quarkus app. So you won't probably see much interesting here. You see the durations, 20 milliseconds, 2 milliseconds. So here you see that it started up in 0.149 seconds. So that's 150 milliseconds. So this was probably a warm start. Or maybe this was probably a cold start because the requests here are handled in 10 milliseconds. So a cold start will be anywhere between like 100 to maybe a couple of 100 milliseconds. Once it's running, it will handle the request in 2 milliseconds or 9 milliseconds, which is pretty fast, I would say. Let's see, logging, load tests. Yes, we can also show some metrics. So I think from here, we can jump to metrics, and then metrics is another tool that Amazon provides to give you some insights, in this case, in the total concurrent executions. You can make dashboards from this. You can put alarms on this. You can put limits on this. So because everything goes into CloudWatch, there's a lot you can configure. For example, what you can say is, I want the max concurrent executions set on 1 or 2 or 3 or 10. I want you to send me an email whenever I run more than 100 concurrent lambdas, because then something may be going on. So there's lots of stuff you can chain together by using CloudWatch events, etc. Well, we're running now here on, what was it? 7x something.execute API. That's not really nice, right? Let's add a custom domain name to it. So we can do this by configuring some stuff in the SAM template. So to run a custom domain name, we need to arrange DNS. The API gateway needs to listen to the domain name, and we need a certificate. So let's start with the certificate. What we're going to do is we're going to ask the AWS Certificate Manager to create us a certificate. The domain name is a reference to a variable called custom domain name. We're going to use DNS to validate. And then the validation will refer to the domain name and to a hosted zone ID. So the hosted zone ID is somewhere below here. The hosted zone ID points to a hosted zone in Route 53. So Route 53 is Amazon's DNS solution. It's basically DNS server for Amazon. And in Route 53, I already have one hosted zone configured. This is demo Bert Jan something.openvalue.dev. And the hosted zone ID refers to this one. The reason why this was the only thing that was present in the account. The reason why is because if I would set this up new, it's somewhere under the openvalue.dev domain. Then now I would also need to go to the domain server of openvalue.dev, point it here, maybe wait for an hour for DNS to propagate. I won't bother you with that. So this is already there. Amazon already has control over demo bertjan1.openvalue.dev. And it's now going to request a certificate for this URL and going to change something in here in this zone to validate the certificate. So let's see, what else can we enable? Well, we need to configure the custom domain name on the API gateway. So the API gateway will respond to that domain name. And then we can add some stuff in the output, some variables. So the custom domain name is serverless API.something. The hosted zone ID points to the Route 53 zone. That's already in Amazon. That handles the DNS. And we also want to output the custom domain name in our SAM run. So this is all configured now. Let's go ahead. What we can now do is just run the deployment again, because it's basically declarative. So it's now going to apply my configuration again to the running environment. So you see that it's not uploading my binary, because I didn't change anything in my binary. I didn't do a new build of my application. I only changed config. So now it's uploading the config to CloudFormation. It's going to add a certificate. It's going to add a domain name to the API gateway. It's going to do some mapping stuff. It's going to delete the deployment. Well, it's created, and now we need to wait. It's, let's see, certificate is in progress. It's going to update the deployment, update my API gateway stage. We probably need to wait a little bit for the certificate to be created and validated, but we can have a look in the certificate manager while we're on the way. List certificate. Oh, it's already issued, so it's there. And now it's going to update my record set group in Route 53. So it now also needs to point the domain name. So API gateway something needs to point it to the API gateway. So now the DNS is being updated as well. The API gateway is being updated. And probably if we go to the API gateway, we can already see the custom domain name there. So here it is, serverless API, demo bertjan1.openvalue.dev. That's available. How far are we here? We're now updating the API gateway is complete, the record set is complete. It deployed a deployment, and it added a new deployment, and now we should be able to reach our application at this nice domain name. So this may or may not work. We'll see. Yes, so now Firefox says, hey, but I can't connect here because the certificate is not valid. This is probably because of DNS cache. So let's try it in another browser. No, let's refresh for a little while. So yes, it's there. So what was happening is I've gone to this URL before, And my browser had a cached entry for this domain name. There's HSTS, which is HTTP strict transport security. So it was pinned to the certificate, etc., etc. Once this is all updated, it may take a couple of seconds for my browser to understand. But it's there now. We can now go to this nice domain name. You'll see that there's a certificate in here, and it was probably issued not too long ago. Well, yeah, they have a start date of 0 this morning, but still, it's there. So now we have a custom domain name. That was also just a couple of lines of config to change. Well, obviously, you need to know how to type in all this stuff, right? So nobody does this by the top of their mind. I just experimented and trial and errored, but all this stuff is on my GitHub, so you don't need to type it yourself. So this whole configuration file should be here as well in the SAM native. So you can just replace it with your own custom domain name, etc. Okay, so the custom domain name is there. Route 53 is there. So Route 53 should now have a pointer to my API gateway. We can check that as well. There's one zone, this one, and it says serverless API demo. There's an A record, and that goes to this domain name. And this D2M35 is probably the domain name for my... No, there's another one that's interesting. That's probably for the API gateway, I guess. Yeah. So this is the internal API gateway host name. So now Route 53 pointed serverless API.demo.something to this URL, which is our API gateway. So that's all set up. We have a nice certificate now. I see you thinking, yeah, but this is all super trivial, right? There's a I don't know, a super simple resource here that just sends back a string. Can native image also do, I don't know, JSON binding or something? Well, let's see. I will start up my local dev mode and go to localhost 8080/hello. And now I want to add, like, this is a conference app, right? So I want to add a speaker endpoint, so /speaker. This is not there, right? Because I haven't added it yet. Well, let's add this. So it's going to be well, a get. The path will be /speaker, so hello/speaker, and it's going to produce JSON. Okay, and I'm going to return with a speaker class. And this is not there yet, so let's create it. And let's create what's it called? A record. Why won't I get generate, create, public speaker? I want to create a new, oh, that's interesting. Maybe because of all this. Oh, let's not minimize it. Here we are. Show context actions. Okay, what's going wrong? It should be able to create a new record now here, right? Any thoughts? Public speaker. Add Maven dependency. Interesting. Okay. Well, let me just create a record here. Usually I can create a shortcut here and then we'll be good to go. Maybe because this doesn't compile yet or something. Let's see if it works like this. No, interesting. Okay. Should work. Any thoughts why it doesn't work? I'll just go ahead here. New, oh, it should be able to create a record here as well, but there we go. Okay. New record is called speaker. And well, yes, let it go get, and it has a name and a tagline. That's what a speaker usually has, right? So public speaker, and then let's put this in here, and then say return new speaker. And this is me, and I'm Chief Troublemaker Officer. All right. So this should now work. Hello, speaker, because it auto reloads, right? Which it does. So now it produces JSON and it marshals it from my Java object JSON. So let's see if we now can deploy this to Amazon, because that should work as well, right? So what we now need to do is build it and deploy it. So you have some background already on how long this will take. I'm going to time how long it takes to build it and deploy it to Amazon. You can place your bets. How long will it take before my change has been completely built, compiled it to a native image, uploaded to S3, applied the CloudFormation run, deployed to Amazon, and available on my custom domain name? What do you think? 2 minutes, 2 minutes 50? Anyone gives less than 2 minutes 50? 1 minute. 1 minute 30. Have you been in this talk before? 1 minute 30 is pretty close, I think. So now we're doing the native image build. We already knew that native image build was around a minute, right? And uploading stuff depends on your internet connection speed, which is amazing at DevOps. Running the CloudFormation run may take some time. Let me go to the URL where we were here, /hello/speaker. It's not there yet. So the native image build is still running, but it's already almost done because we're step 5 of 8. And then it's going to do the same as you've seen before, right? So it's going to upload the new thing to S3. Here we are. And then use Amazon SAM to run a new CloudFormation run, which will probably only update the Lambda and replace the binary that's in the Lambda with my new binary. So, waiting for the change set. Probably going to update the serverless deployment, I think. Yeah, Service API deployment. I was going to modify the REST API as well. Interesting. Maybe because a new function gets deployed and the REST API needs to point to this new function. Well, it's already there. the CloudFormation run is not done yet, but it's already responding with my new endpoint. And it took 145. So usually it's like 130, 145 for a complete build and deployment on my local machine. Obviously, if you run this in a pipeline on a build server, probably be able to go even faster, right? So that's there. Well, we don't need to go for a break again because we still have loads of more things to do. Let's throw everything away we've built to get rid of it. So I have a script for that, obviously. Destroy, and destroy will say SAM delete. Does anyone feel bad about me destroying all the amazing stuff we've built here? No? Good. Then we're good to go. Did I say deploy or destroy? Destroy my robots. So it asks, do you want to delete the stack? Are you really sure? Yes. Do you want to delete the folder? Yes. Now it's going to delete my CloudFormation templates, the S3 stuff, going to delete the serverless API, so probably it's already gone by now. Yes, internal server error because my Lambda is gone, and in a while it will not give me back anything anymore. All right, so it's time to continue and to talk a bit about the migration I did from Spring to Quarkus, because the NLJUG app used to be a Spring app on VMs, and now it's Quarkus on Lambda. First, the migration of the REST endpoints. Here you see how it was in Spring. So we have a REST controller. There's a mapping on there. There were some cross-origin stuff on there to be able to use from front ends. There's a service here that gets injected by constructor injection. And then there's an endpoint that has a post mapping. It has a request body. So this is when you vote on a session, you basically send one post with this is the session ID, this is my score, this is remarks. It will call a service to register the vote. That will in the end go to a repository that will go to DynamoDB. Okay, done. Well, if you convert this from, this was then the Spring dialect to the Quarkus, or actually the JAX-RS, Jakarta-I dialect, it will look pretty much the same. So I have a path instead of request mapping. I added some security, so roles allowed is the Jakarta-I security. I'm using field injection here because there was no constructor injection. So this is the CDI, context and dependency injection from Jakarta-I. The annotations are a bit more verbose. There's a post, there's a path, it produces JSON. This is all in the post mapping in Spring. I have a permit all because you don't need authentication to vote on sessions. And then this pretty much looks the same. It's a Jakarta-I response instead of a Spring response entity. It will also get a POJO that represents the request. It will go to the service and it will send OK. So this is just from one dialect to another. Nothing special here. Then the rest entity classes. So this basically corresponds to one post you do from the app. So which event is it? What is the type of the post? What session do we refer to? What was the question? What was the answer? Are there any remarks? So when I built this, Kotlin was becoming cool. I wanted to become cool as well, so I used Kotlin. Then, yeah, so do we have Kotlin fans in here? Only 2, 3. So I use Kotlin, but I use Kotlin in a way where you don't need to learn Kotlin because I only use data classes. So basically, I use Kotlin instead of Lombok, right? But to use this in Quarkus, well, my friend Jago, who's a Quarkus fan, he was walking by because this was a hackathon. He said, "Oh, you shouldn't use Kotlin, you should use records." And I said, "Records, come on, records, all this modern stuff. I'll use the great language of Kotlin." And then it didn't work right away. So obviously, with data classes, they get compiled to some Java bytecode, and then this needs to be marshaled by Jackson or whatever to go to JSON, and it didn't work right away. So first I said, well, screw records, I'm going to go with Kotlin. And then I couldn't get the Kotlin marshalling working directly in the native image. And then I tried records, Java records, and Java records worked out of the box. So then, sorry for the Kotlin fans, but then I said, screw Kotlin, Java records rule. And well, it all went downhill from there. So how did it look in Java records? Well, pretty much the same, right? So a record is not that much different from a Kotlin data class. You have a bit more options in Kotlin, but this was fine enough for me. So I think the only thing I needed to add was, is this a Kotlin fan leaving now? I'm sorry, 2 even. 3, oh no. I offended all 3. I'm sorry. So I think this is where I needed to add that JSON-B dependency that I showed you in the beginning, like the rest easy JSON-B. I need to do that to be able to marshal records to JSON. So, well, then any other changes I need to do? I have a live image from me looking around for the other changes that I need to do. This was already it. So I was a bit lucky that I was using DynamoDB already. And the SDK from Amazon I was using to call DynamoDB was already compatible with native images. So I only need to migrate to Quarkus, fix the records, and fix the REST templates, and then everything was working already. So obviously my app is trivial, right? So it takes one request, it saves it into DynamoDB, and there are some management endpoints that will allow you to get reports on votes per session, etc. But that's quite simple. If I would have done, I don't know, Spring Data or JPA or Hibernate, I would have needed to do more work. On the other hand, Quarkus supports this as well. It supports it in native image mode as well. Quarkus has Panache, which is an ORM framework that works quite well and is super comparable to what you would do with Spring Data, JPA, and Spring, for example. But I got a bit lucky here, I would say. So to show you a little bit of code from the actual NLJUG backend, it's again based on the template. So the same template I've been showing all the time. And let's go here. Any stuff that's different? Let's see. There are some things here, new things that you didn't see before. So I have a page that shows some information about the API, and this uses Qt template rendering. So there's here a method that says render, and this will call this method, and this will create a map. It will put some data into that map. So this is context for the template rendering. So what's the event ID, what's the session ID, and then we'll call API.render. And API is over here. It's a template. This corresponds to a file that's here in templates called API.html. So by creating this context map here with event ID and session ID, I'm able in that template here to replace these things. So just like the old days when you're using JSP or JSF, you can do template rendering with Qt, which is just one Quarkus plugin you need to get here. In terms of the flow of requests, there's obviously the resource. So there's the voting resource. That's the one you just saw. So if you vote for a session, we're going to the voting service. And the service needs to map some stuff because we've had different versions in the app before where sometimes you would get a number and sometimes you would get a string for a vote. So there's a mapper here that fixes that. Then we go to a voting repository to store the vote. And the voting repository basically creates a map with ID, event ID, those kind of things that we saw in DynamoDB. and then puts the item into DynamoDB. So all that you need to do to write to DynamoDB is this. I have a DynamoDB client here that's configured, it's injected, put item, and then there's a request builder, there's the table name, which is NLJUG events that you saw, and it puts this item in there. So this item is a DynamoDB item, and then it's there. So this is all you need to do to insert. If you want to do queries, then it becomes a bit more complex. Let's go here, let's see. This is get session data for an event. So this will get everything from the sessions table, basically. So what you need to do is make a scan request, and this is something you can use to scan a table. And then we're going to call DynamoDB, say do a paginator, do this request, get all the items, map them here, and then because I'm lazy, I'm filtering everything on the client side here, because there's only like, I don't know, a couple of hundred sessions in there, so just get them all, filter them on the client side and move on. If your table is bigger, you probably want to do some server-side filtering there, right? Let's see, the POM is pretty much the same. I have some static content as well. So here we saw the templates. So these are HTML files that are being processed by the Qt template renderer. But there's also in your meta-env resources, they're just like index HTML that has a logo and something like this, and a login page, etc. So if you place them here, either in your templates or in your meta-env resources, they will be packaged inside your native image, and you can use them as well to access them. So you could, for example, also copy your entire front end here and package your front end together with your app in your native image. I'm not sure you'd want to do that because you probably want to put your front end just on a web server, on a content delivery network or anything. But you can streamline static resources in your Quarkus app native image as well. They will just be able to access them just over HTTP. Let's see. Yeah, there's some stuff in the properties. If I did everything well, I threw away all the stuff that's not for your eyes. So I use just form authentication to log in here. Simple username, password that I won't tell you, but that's in the login file here. So it's just a post that sends a username and a password to Quarkus. And because I've configured HTTP authentication here, that's all I need to do. Quarkus will look for the username and password parameter and then give me a cookie that's valid for 12 hours to log in. So this is all I need to do to create basic username password authentication in Quarkus. And then it will set a user and a role. And this would allow me in the resource here to use this permit all or roles allowed NLJUG somewhere. So there should be... so by default, this is protected, and only someone with the NLJUG roles be able to access this. Let's see, POM, static content, built-in properties. So I have a resource that gives some info about the app. It will give the Quarkus version, the Maven build timestamp, etc. So these are config properties. So if I go to the info resource, this will basically show the Quarkus version, the Maven build time, etc. They will be got from here. These files are filled to config parameters, and these are basically either already in the property file, or they are created by, I don't know, some kind of Git plugin, the Git commit ID plugin. So the Git commit ID plugin will replace some stuff in my property files with the git commit, git hash, etc. So all this works just to show what you do in a regular project. This all happens at Java build time, so you can do all those things that you're used to and run them in your native image as well. So let's see. Yeah, so one remark. So how I'm accessing DynamoDB here is through two keys. So I have a static provider, so there's an access key and a secret access key to connect to DynamoDB, which means that I'm not using anything of the Amazon stuff to connect. I'm just giving a username and password. As a result, I can run the app locally here, connect to my production database, and it will work right away. If I build and deploy it on Lambda, it will work the same. There's no specific access role or something. It will use that username and password to connect to the Dynamo database. Is that optimal? No, but in my case, it's super useful because I only have my laptop and production. So if I run it here, I'm already talking to the production database. If I deploy, it will talk to the production database as well. In serious scenarios, you probably want to set up some kind of access roles where the Lambda is able to access DynamoDB through Amazon access profiles, basically. All right. So to share some experiences with running this stuff in production. Well, first about monitoring. These are the metrics from JFall 23, which was the first time when we ran this. So Amazon had no idea about the traffic this app was going to cause, right? So the number of invocations, and this is per minute, I think. Well, there maybe were at max a couple of 100 invocations per minute, which is not that much. The duration, how long did it take? Well, this green line is the maximum. So 1.1 second. Maybe here 2 seconds, but in general, the maximum hardly goes over 1.1 second. And the average is this line here. So that's, we're talking 1.3 millisecond. So that's relatively fast. Everything went well, no errors, it didn't throttle, and it scaled to a maximum of 17 concurrent Lambdas. So why at 8 in the morning does it go to 17? Probably depends on whether this is UTC or not. So this can either be during the early bird sessions in the morning or during the afternoon keynote, the morning keynote. So why 17? Well, I was discussing this with some of the people from the Lambda team, and I said, why does it scale to 17 instances when there's only like maybe, I don't know, here, 170 calls per minute? And then I said, probably Lambda got scared. So it had seen no traffic at all. Then some significant traffic and said, oh, I need to scale to 17 because it's going to be super busy. And then a couple of minutes later, they go, okay, nah, man, I just need 1 or 2 instances. And then here, this is probably during the afternoon keynotes. It scaled up a little bit as well, but maybe to 15 instances. And then back to 1 or 0. So number of invocations, you see some peaks here. This is in the morning. This is during the morning keynotes. This is after the morning keynotes. This is, I think, after lunch. Well, you see some peaks in usage at max 100 invocations per minute. But these peaks are interesting. So these are peaks that can be tied to moments in the conference, like keynotes. But here, there's a peak, the biggest peak for the day, and it's like at 1650 or something. So either there was somebody in a big room that have everybody vote at the conference app at the same time, or I don't know, somebody found a curl script to send 100 votes for their own session to get a great rating. Who knows? Request duration, so this is a 1 minute average. Again, we see orange is average, it's super close to 0. And the max almost never goes over 1 second, which is fine. You press vote on an app, you get a reply in a second, and usually in milliseconds here. Here again, the average, you see the same graph. Success arrow count, only successes, so that went pretty well. Concurrent executions, well, 16 and 14, so also not that much. You can see the logs, but we always seen this, right? So you can get them with SAM logs, you can get them in CloudFormation. What is interesting here is to see that you see Quarkus starts up here because this is the logo. The first request took 172 milliseconds and the second took 2 milliseconds. So the cold start here was about 170 milliseconds, which is still perfectly fine for a user to wait a little bit on. Costs. How much do you think it costs to run this? So before, the costs were about, for conference month, maybe 50 to 100 euros a month. How much do you think this costs? Just shout. 0, 3? What unit are we talking about for 3? Oh, for free. Well, you're pretty close. You're both pretty close. But 3 was pretty close as well. It's close to 0. So these are regular months. And I pay, I don't know, 3 cents for S3 because there's, I don't know, a couple of kilobytes on S3. Then conference month, pay a little bit for API gateway, maybe a cent, and a little bit for CloudWatch because there's more logs coming in. And those logs need to be stored and you pay for those as well. So if we zoom in a little bit, S3, 3 cents, API gateway, 1 cent, Lambda, nothing. So all this CPU and processing memory time cost me nothing. CloudWatch, 4 cents, that's it. So this is pretty much running for free here, right? I have 2 more bonus topics to show you, but if you have any questions you'd like to ask about Lambdas, about the NLJUG app, anything about the stuff we've talked for in the past 2 hours, happy to take them. Anyone who wants to ask questions? Yes? Did I look at all our fast platforms? You mean in terms of stuff that starts up fast? Ah, yes. So why? Basically, the question is why did you go for Amazon Lambda, right? And not for all the platforms? Because I was already pretty much fluent in AWS and everything that runs there. I started out with the Quarkus template that deployed to AWS, so that pushed me in terms of AWS a little bit. The SAM tooling worked pretty nice. You can pretty sure do the same thing on like Azure Functions or Google Cloud Run, which is basically serverless within a Docker container. I use this because the tools pointed me in that direction and because I was experienced in this direction. So you can pretty much do this also on, like this OpenFast, you can run on Kubernetes in your own data center. There's lots of cloud providers that do serverless stuff. So not really a good reason, just that it was easy. Any other questions? Yes? Ah, yes. So the question, if I understand correctly, is now everything in one Lambda, or do you have multiple Lambdas deployed? Yeah. So the question is then maybe a bit about deployment models, right? So how could I deploy this application? I used to deploy it on a virtual machine that would run all the time, but I wanted it to go to a situation where it would scale back to 0 easily, so it wouldn't cost me anything. So I could have probably deployed it in probably the free tier of Amazon Elastic Kubernetes Service or Amazon Container Service as well. That would have worked. I chose to go for Lambda because, well, Tim told me to. And Tim is usually right. I like to experiment with Lambda, but I could have done it in a multitude of other ways. Could have been on Kubernetes. You could do Elastic Beanstalk, that basically runs a jar. Elastic Container Service, Elastic Kubernetes Service. There's loads of different ways to deploy. Why I like Lambda is because it scales. It can scale super quickly and scale back super quickly, which matches well with the traffic characteristics of a conference. So even during the day, people usually only going to vote at the end of a session, right? And not during the day. So also the traffic there is quite unpredictable. You also asked something like there's now one Lambda which has everything. So the idea behind Lambdas is that you deploy usually a landscape of Lambdas, right? So only single functions, etc. I now basically took my traditional REST app that has multiple controllers, multiple endpoints, compiled it all into one binary and deployed that one binary. I could also split this into multiple Lambdas and multiple binaries so you can build and deploy them independently. The reasons to do this are basically, I'd say, the same reasons on why you should deploy one monolith or multiple microservices, because you want to upgrade and deploy and scale them independently. So if there's one part that needs to scale a lot more than the other parts, then I might deploy those in 2 Lambdas. Maybe I have one Lambda for the management interface that only scales ever to one instance, and then the voting endpoint as a separate Lambda that scales to I don't know, 10 or 20 instances. In this case, it was all small enough to put it all together, slap it in one Lambda and get going, because it also made it easier for me to run and deploy these things. But not really good reasons on why I shouldn't do it otherwise, just that this was the first thing that came to mind and it turned out to work. Yeah. Yeah. So if a Lambda gets a request and this Lambda is cold, means it's not running, then the first call will be relatively slower than the rest. So it will need to start up the Lambda environment, which is probably a Docker container. It needs to load my binary, start up the binary, start up the app, and handle the request. But you could still see this was 172 milliseconds or something. So slow is relative, all right? So the people who were talking about a Spring app starting up in 30 seconds, they would find a Lambda starts up in 170 milliseconds pretty fast. So a Lambda does not immediately get shut down after it's done running. So usually Amazon keeps a Lambda running after a request for about 15 minutes or something. So in those 15 minutes, it will still be all response in 2 milliseconds. Not until there's no request anymore, then you get scaled back to 0, then the first request will be slow. But it's not every first request. It's only the first request if it gets handled by a Lambda that is called. Any other questions? Yes? It's good that you speak because I wasn't looking at you. Go ahead.
I use an API gateway event as a trigger for your Lambda.
Yeah.
But if you use like an S3 or an SQS event, would it also arrive as a REST?
Yeah. So the question is, I'm now using a API gateway as a trigger to send events to my Lambda. If I would use something else, like a SQS message or something uploaded on S3, would it also arrive as REST? No. From the Lambda perspective, everything is an event. But since I'm using the Amazon Lambda plugin for Quarkus, Quarkus makes it that an event coming in from an API gateway will look at as a REST request for me. What will happen if I send an event from an SQS queue to my REST Lambda? I have no idea. I haven't tried it. Well, I don't know. I think the app is now pretty much tailored from my code perspective on REST. So I'm not sure that anything else than REST would work here, because it's wrapped in some kind of a REST proxy by Quarkus. So we should try it.
Does Quarkus also have other kind of handlers?
Yeah, so the question is, does Quarkus also have other type of handlers to basically figure out handling Lambdas from S3 or other things? I don't know, but what you could do is not deploy your app with the Quarkus API gateway native image plugin, but just build a regular Quarkus app and implement the handler from AWS to process request and move on from there. Then you could handle any type of request. So then probably if I would need to handle, I don't know, messages from S3 or something, or from SQS, I would build a different Lambda that does not REST, but just implements the handler interface, deploy that as well, and just have them separately from each other. All right, I have 2 bonus topics. The first one is about websites. So I also used the same stuff to build a backend for a website. So the use case is a static website. So the open value website is built using Hugo. It just generates static HTML, which is fine, but every now and then you want to do something dynamic, like having a form on your page where people can contact you or apply to work at you. So the first version we had here was we used HubSpot, which is a CRM that you can use, and HubSpot offers forms, and HubSpot also offers JavaScript integration. So we only needed to configure a form in HubSpot, add some JavaScript to a website, everything was fine. And it's funny that Ramon just walked in, because the problem I'm just going to discuss, it hit Ramon. Ramon said, yeah, it's been pretty quiet with requests for training the last couple of weeks. What's going on? Well, after a while, this was going on. A live image of Ramon seeing emails come in from people who want training. No emails were coming in. But people were calling us like, I sent the form on your website, but you didn't call me back. So it turned out that because of browser security settings, having your website that goes with JavaScript to another website to integrate a form, some security setting had changed in Chrome or Firefox, and the forms weren't working anymore. So people were typing in the forms, but we weren't getting any mails. So as a result, our emergency fix was we put an iframe in our website that integrates the frame from HubSpot. Super ugly, but it worked. So then we wanted to make this nice. So the first idea I had was to basically use some kind of SaaS backend that would offer form functionality, just have a form in a website, do an HTTP post with a regular HTML form to the SaaS backend, get the emails there. Turns out I wasn't the first with this idea, because some people have built these SaaS backends, and I guess they are rich because they are pretty expensive. This was like 10, 20, 30, 40 euros a month. I'm said, screw that, let's build something ourselves. So the fourth version we built was a form integration. So basically, this is an HTML form, and it's also like an old school HTML form in the HTML. It will send stuff to some URL, send the fields, and then we'll transform this in an email. So the architecture for this is pretty similar to what we saw for the NLJUG, right? So I used the same template project. Somebody sends a form, API gateway sends it to a function, and then we use Amazon SES, the simple email service, to send an email. So we're done, right? We can go to lunch 18 minutes early, and we'll be good to go. Everything live, and then next day, open my mailbox, boom. Who are these people? I deploy a form on my website. Next morning, Amazon mails me that my simple email service quota have been exceeded. Hundreds of mails. Who does this? Somebody is actively, I think, scanning websites, filling in forms, but even with like bogus stuff, right? So this is not even spam. This is just, I don't know. So, okay, we need to fix this. So, I figured that an IP blocker should work, all right? So all we need to do is get the remote IP from the person who sends this and block them. That leads to this beautiful piece of code. So it turned out there's multiple proxies involved. So somebody sends their form post to the OpenValue website, which proxies to an Amazon API gateway, which proxies to a Lambda. So these proxies, they put the remote IP in the x4 header, but there's now a double proxy. So in order to do this, we need to read the x4 header, then there's multiple IP addresses in there, and then get the second to last, and this is the IP of the person sending, well, just a big mess. But we now knew the IP of the senders, and we were able to block them. So we built a blocking table in DynamoDB, and we would block those IPs. So we're done, right? Next morning. Boom. What? I just built an IP blocker. Why isn't this working? Well, it turned out those spammers have botnets that have different IP address. So we built the whole IP blocking stuff for nothing. So, in the fifth version, we added a CAPTCHA. So Google CAPTCHA is quite easy. You just add a couple of lines of JavaScript, and then when somebody fills this in, you get an extra post field to your backend, and this is a field you need to send to Google to validate, and you get true or false back. So this is only maybe like 5 lines of code to integrate in CAPTCHA in your website. If you ever need it, super easy to do. So now our next architecture looks something like this. A user sends form fields, then we check if they're blocked or not. A Lambda function gets called. Here we check the block list, then we check the CAPTCHA from the browser, send it to Google, and then send an email. So, are we done? Yes, finally we are done because of the CAPTCHA stuff. So we probably could have skipped the whole blocking stuff and done a CAPTCHA right from the start. So some experiences here that are pretty similar to the stuff with the NLJUG app. So we did use a pipeline now. So on GitLab, whenever you push, the native image build gets done, and then basically it gets deployed. But you see here in the bottom already, it's just the same deploy script, right? So this runner installs the AWS CLI, it installs the SAM CLI, it configures the AWS credentials, and then just runs the build script and the deploy script and runs the CloudFormation run, and you're good to go. So it's pretty trivial to put this in a pipeline, and you just push from your local machine, and it will be in Amazon when you're done. So logs, the same, just as we've seen before. Here you see somebody failing their CAPTCHA verification, so there's at least one spammer less on the planet. Usage, I found this pretty shocking. So there's, I don't know, this is in one day, hundreds of requests. So I didn't know our website was so popular, but spammers, I think, love to send these things. But we're blocking pretty much most of them now. How much spam do you get, Ramon, per day? Maybe 2 or 3, but that's better than 300, right? And these are the people, I actually admire those people because they take the time to take their browser, to type their spam stuff in, to complete the CAPTCHA, and then send it to Ramon. Well, at least they deserve Ramon reading those mails, right? Or maybe they've automated it, or I don't know, they have a monkey trained to solve CAPTCHAs or a robot, I don't know. But still, I find it quite impressive. So latency seen from the API gateway, this is max. Max is maybe like 2.5 seconds. Well, if you press a button on a website and it takes 2.5 seconds to say thank you, your mail is sent, It's a bit slow, but it's okay. And this is max. It's usually a lot less. On the Lambda, again, here you see the maximum is 1.5, maybe 1.7 seconds. But the average are the orange dots that are pretty much more like 500 milliseconds. And in those 500 milliseconds, we process the request, we go to the block list, we validate the captcha with Google, and we go to a simple email service to send an email. So that's okay, I would say, for 500 milliseconds. Some stats for the captchas. So, well, here people were figuring out in the beginning that their captchas failed. Now it's okay. We get some ones that actually go through, but these may also be valid test requests. Some don't have a captcha, we block them right away, and some fail. They fail their captcha because they fill in a dummy value for the captcha, for example. So the cost. Well, also pretty flat, right? We do see here there's a significant cost of 50 cents, the blue stuff, because of Amazon Route 53. So the Route 53 here, I don't know, for some reason cost 50 cents, and in the other one it was free. Maybe because I don't know, you probably get like one free Route 53 zone per account. Probably I already had another one in this account, and therefore now I need to pay 50 cents a month. It's a shame it's not 53 cents, right? But well, we'll leave that to Basil and his friends. I pay some tax, and then, well, yeah, this is also cents. So instead of paying those form SaaSes, 30 euros a month, we're now only paying 17 cents. And we also spent a couple of weeks of man hours to build this, but that was fun, right? So who cares? Any questions about this use case? It's pretty comparable, I would say, but you do see that for these type of things, the same setup works pretty well. Because I had this project already laying around, it was quite doable to take this and build something that does pretty much the same, but now not process votes, but sends emails. Again, the use case here, it fits pretty well with serverless, right? We get a couple of people, well, I thought we would get a couple of people per week sending in the form. Turns out to be more, but it does scale back to 0 quite often. Questions so far? Good. Then I have our final bonus topic before we wrap up. We have around 10 minutes left. And this is about a bit more serious application. So for a customer of ours, we are building an extranet where clients can log in. And this does run on Quarkus, on GraalVM native images, but on Kubernetes. So this used to run on Spring, and then it's quite an extensive extranet where there's, well, a UI application, but it needs to send and pull lots of data from different sources. So there are lots of messages being exchanged by queues, and after each queue, there's a consumer processing data for that queue, then doing something and putting something on another queue. So there are lots of running bits and pieces. And in the end, this was a microservices landscape of 10, maybe 20, maybe 30 services. And this was running on Azure, on Kubernetes. And at some point, somebody started complaining about the Azure costs. Because if you're running 10, 20, 30 microservices, maybe with 2 instances on Kubernetes, you get quite some overhead. So to start up a JVM, how much memory does like a bare JVM need? Any thoughts? Just shout. Yeah, 250. I was thinking order of magnitude 100, 200 megabytes, just a bare JVM. Then your application gets on top there. If it's a Spring app, then you know, some class loading, some I don't know, Hibernate stuff. You easily like a couple of 100 megabytes that you on OS level that you need. Even if you limit your JVM to like 256 megabytes, then still you need to add the 200 megabytes that the JVM needs to start up. So let's say one service needs about 500 megabytes. Well, if you then have 30 services, how many memory do we need? That's like 15 gigs, right? For a small application. So this is the downside of running lots and lots of different instances of services in lots and lots of JVMs, that the overhead starts adding up. So people started complaining, why is our extranet, which is a not super complex application, using so much memory? Well, because of we have explained to your business that you have a microservices system, that there's JVM overhead, etc. This is difficult, right? So here we move to Quarkus and native images to save memory. because going to native images, those applications also weren't that complex. They connect to queues, they have REST endpoints, they connect to databases, but still doable. So there, by moving from Spring on VMs to Quarkus on native images, we were able to cut a significant amount of the memory that was used. Because those native images, they don't need to start up a JVM. They are pretty slow, pretty small. They don't need to do dynamic class loading. So they can run maybe in, I don't know, we have, let's go a bit back here in the logging. We can probably see how much memory it used. No, not here. I need to go back a little bit more to the logs from the NLJUG app. Here. So duration, 172 milliseconds. Memory used 77 megabytes, 78 megabytes. So that's a lot less than those 300, 400, 500 we were talking about later, right? So we were able to save quite some memory there, and therefore able to save quite some cloud costs because we could run on smaller Kubernetes clusters, etc. That was doable. How we do run there is that we run locally on JVM mode, and once you push to the build, then the build pipeline starts building native images and deploys that to the test environment. I think that's a good middle ground. You can just run the Quarkus development mode, run on your local machine with auto reloading and those kind of things, and once you push to your build pipeline, then it will be a native image from then on, because I do feel you need to start testing a native image earlier than production. So preferably like a test environment or something there. Let's see if I'm missing anything for you. No. We have 7.5 minutes left, so it's time to wrap up. Is this the holy grail, no pun intended, for software development? Well, the development experience is super easy. It costs almost nothing. You can build and deploy straight from your laptop if you're the only developer or use pipelines. But there are some caveats, obviously. If you need to cross-compile across CPU architectures, this is super slow. So preferably make sure that your development machine and your build server and your production are of the same CPU architecture. I solved this by doing everything on ARM. If you have ARM laptops and, I don't know, Intel servers, your mileage may vary there. Third-party support for native images is not guaranteed. So I had some trouble. I think I can actually show you. I had some trouble with a cache somewhere in the NLJUG backend, which is probably here, I think. Let me find it. Register for reflection. Yes, here. So I had some issues with, I'm using like a cache to cache some session data. And this worked fine in JVM mode. And when I ran in native image mode, it complained that some class could not be found. So it turned out that this cache that's used in Quarkus, it needed to dynamically load these cache strategies or something. I'm not sure what this is. Well, let's have a look. Yeah, it's a caffeine caching library. It's probably some kind of caching strategy or something. These classes couldn't be loaded because they're loaded by reflection in this library. So I did need to add an annotation here that says register for reflection. So with this, you instruct the native image compiler that these classes may be loaded for reflection later. So you can already streamline them in your native image build, so it won't break later when the app tries to dynamically load them. Not really, they will be in your native image, but if you don't do this, then you get stuck. Probably this is already fixed because it's a Quarkus library, but that's being maintained by Red Hat. But I left it in here just as an example on how you can solve if you get reflection issues with third-party libraries. So reflection native images can be tricky. If the problem is not local, then debugging can be painful. Even if the problem is only your native image, it becomes a bit more painful because in terms of turnaround time for fixes, locally I have my Quarkus dev setup. I can test it in 1 second. If I need to build a native image and run it, that took like 1 minute, 1 minute 10, I think, right? To do one development cycle of running a native image locally. If it needs to go to production, that took how long? 1 minute 30, I think, right? So that's okay, and it's not much different from debugging something in production on your Spring app that runs on containers on JVMs, because that probably also takes at least 1 minute and a half to get in production, but it can be painful. There was one issue I remember with authentication, where I was building something with authentication. It worked all fine locally. It worked fine locally in native image mode. It didn't work in production. So it turned out that locally I'm accessing my native image directly. In production, I'm accessing it through the API gateway. So the remote domain from the user that I will bound my cookie to didn't match up. Is this a native image problem? No, it's a proxy problem, right? So it's not necessarily a problem for native image. It's a problem I experienced by the way stuff was set up. Probably you need to set limits on Lambda on your API gateway to make sure that people won't, I don't know, hit your wallet by sending loads and loads of requests there. And it's probably good to use some build and deploy pipelines anyway, right? So for me, I'm the only developer. I can just build and deploy for my local machine. For our website backend, there are a couple of more developers, so we set up pipelines. But they're basically doing the same stuff I'm doing on my laptop locally. So, to summarize, it's totally doable to do serverless Java apps in 2025. It's amazing with Quarkus and Graal. It's super easy. It's ideal for small or hobby projects like the backends I show you, but it works for larger, serious projects as well. Obviously, if you now have a Spring app of 100,000 lines of code or 1 million lines of code, it may be a bit more difficult to get there. And you should also ask yourself, is this really the way to go? Because there are specific use cases for having serverless stuff and specific use case for having long-term JVM running stuff. As usual, your mileage may vary. So if you want to start playing with this yourself, all the instructions are on my GitHub, github.com/bertjan/this long name, get an AWS account, install the CLI, install SAM, get Java, get Maven, and you'll be good to go in an hour or so. So that's it. I hope you please go kick some ass with your newfound knowledge. Just a couple of closing words. If you have any more questions, feel free to come over. Happy to handle them. And you can find me at the ISAQB booth tomorrow. So as I said before, the ISAQB is a foundation that offers software architecture education. I'm a volunteer there, so I work on evolving the architecture curriculum. I'll be at the booth, well, I'm pointing that way, but it's down here, at the booth tomorrow the whole day. I also organize a software architecture meetup in the Netherlands. It's on meetup.com/ISAQBNL. So if you're ever around, usually sessions are in Utrecht. We're discussing software architecture topics there. It's fun to join. Worst case, you have a boring evening, but still free food and drinks, so it's a win anyway. And that's about it. There's just one more thing I want you to ask, and just please provide feedback to this talk through the DevOps Companion. As always, be honest, but also be generous. Thanks a lot for your time. You're an amazing audience. I hope you have a great time at DevOps this year.